Hello and welcome, everybody. Hello. Hope you had a great lunch. Welcome to the Deep Frontier stage. We're talking about the new European defense architecture. My name is Chris Burns. I've covered armed conflicts. I've been in Brussels for a long time. We're talking about defense and how do you up our game on defense here in Europe. Despite my California accent, I am also, je suis citoyen européen en plus. So I have skin in the game as you. And that's what we're talking about. We're trying to adapt to this changing geopolitical situation, which actually is changing almost in real time, right? And how do we seize this challenge as an opportunity, as an investor, as a startup, as a company? That's what we're talking about today. We're talking about the shift from national to European defense union. We're talking about increasing industrial capacity, about joint financing, about investment. The EU, the European countries, spent 340 billion euros in 2024 on defense. Why? And that's the second largest budget in the world on defense. Why aren't we stronger? Because we have to make it work better together, right? We're expected that last year 380 billion. It keeps going up. Right? Yes. How many of you went yesterday to the liftoff event, Cosmos liftoff event, in that skyscraper last night for deep tech? Anybody? Couple, maybe, 2, 3. Yep. I talked to a Japanese investor who's based in London, who's here to invest in companies in Latvia. Right? That's what this is all about, that we all have to look at investment as being across the world, investing here in Europe and collaborating. We need more startups, we need more joint procurement, we need more jobs, right? Today we're going to be talking about sectors today on autonomous systems, infrastructure resilience, cybersecurity, critical infrastructure, space tech, semiconductors, quantum computing, you name it. And in between all that, we'll have a networking break halfway through with Slido questions for you. So be ready for that. You can answer some Slido questions on that. A couple of tech tips, or a few. We are streaming. Hello, everybody, whoever's watching from afar. We have Wi-Fi, which is Deep Tech Atelier 2026. You can see it on the walls around as well. Password, Deep Tech is sexy. All one word, deep, capital D, tech, capital T, is, capital I, sexy, capital S. Deep tech is sexy, which it is. We have live translation. Use the QR code on the side of the stage. Where is it? There it is. Live translation. It is not the gospel truth, okay? This is AI. So forgive AI that it's not always exact, right? So if you find something very strange, have a laugh and put that in perspective. Networking, you can open the badge.me app online. You head to the Discover section. You can invite people. This is all about networking, of course. Invite them to the B2B section or the networking area. Did you check out the demo zone with all the great toys? Drones, 3D printing, submarine stuff. This is really great stuff. Check it out. It's really, really good. And network with them as well. Food truck outside, if you haven't seen it yet. And the hashtag. Lots of different hashtags, but I've been using hashtag deep tech. Hashtag deep tech. Yeah. And if you have, because this is very tightly planned, we don't have time for Q&A, but if you want to connect with me on the Badge Me, and send me a message in the chat, I will try to get to your question. If you have a burning question, let me know. All right, and speakers, please all stay to time. Networking reception after all of this. Okay, let's start with the opening keynote. And we're talking about the Baltic perspective on the new European defense architecture. How do the Baltics fit in? How does that Baltic tiger fit in to all of this? And I'd like to call up someone who I knew him very well as a member of the European Parliament. but also Vice Prime Minister, Defense Minister, Foreign Minister of Latvia. He is also CEO of MITEC Latvia. That's an association of drone and robotics manufacturers. He's also chair of the Northern Europe Policy Center. That's a think tank. His name, if you don't know it already, is Artis Pabriks. Artis, please give a big hand to Artis. And he has a toy. He has something to show us. Artis, welcome.
Thank you very much, and thank you everybody who is here. And since I'm representing here MILTEC, the Latvian Association of Drones, Robotics and New Technologies, I cannot come without one of them.
Absolutely.
And just for you to know, before I put it on front of you, this thing, it costs less than 1,000 euros, but it can kill millions. This is the difference what we are talking about in the last years. And before we engage in a discourse with... is
that going to stay?
Stay.
Yeah, there you go.
Don't fly anywhere.
Yeah, don't move.
With Chris, I also would like to ask you some questions. It's a quiz as well. So we all know that these things appeared in a military use after the Russian invasion in Ukraine, starting with 2022. Imagine, 3 years ago, basically nobody was speaking about these drones. Now everybody speaks about them and similar stuff just because they are determining who is winning and who is losing. But tell me, when the first drone ever have been crossing Atlantic Ocean from Newfoundland to Scotland? Tell me the year, who knows?
What was the first Charles Lindbergh drone to go across?
Anybody? 1998. Now, the second question is, do you know the name of that drone? So, Latvians, learn your history. How? No, it was Laima.
Laima.
And Laima is the ancient goddess of Latvia of luck and happiness. And why it is Laima and why it's crossed? Because there were 2 attempts before, they did not manage. Because on the top of this drone experiment in 1990s was a Latvian engineer and professor, Juris Wagners, who was exiled from Latvia because of the Russian invasion during the Second World War. He lived in the US. He's still alive. I spoke to him. And so this is why, when Chris speaks about Baltic tigers, this is why we consider Latvia really a tiger as far as drone industry, as far as the drone equipment, because we have a history behind, and it's very important to know this history. So from first Laima, 1998, to many factories in Latvia which are producing drones. Just in our association, from 54 members, producers, 40% are drone producers, air, land, and sea.
Right. Artis, so before we go into, what we want to do is we want to give you a bit of a geopolitical, because it's, former foreign minister, former defense minister, MEP, you've got that background, the gravitas to tell us about the geopolitical so what behind deep tech. And there are two, and we're talking about that new European defense architecture. There are 2 things I'd like to mention before you get started. There was a European Parliament study recently on the future of the European security architecture and dilemmas for the EU strategic autonomy, talking about scenarios that are increasingly antagonistic in the world, including what degree of US engagement in Europe, the EU-NATO relations, and the outcome of the Ukraine war. The second one is a roadmap for defense autonomy, because we want to talk about that, sovereignty autonomy, by the Kiel Institute, that does mention that we in Europe have the 2nd largest defense budget in the world, but we need to address gaps, including drones, air defense, space launch, satellite recon, electronic warfare. That's what this day is all about here on this stage. That's what we're talking about. How do you see the urgency of building a new European defense architecture?
Well, all architecture for any building starts with a fundament. So if you are building a castle on the sand, like it is told in Bibles, then probably it will collapse. And I will since we have limited time, I will touch upon a number of things in this construction of, our security networks. And I think we can learn very much from such a situation where we all have been just some years ago, which is COVID. And you know, before that, we were dreaming about global collaboration, about global village. We produce some things here and some things there. We do everything what is cheaper somewhere else. And then, even in this country also, we woke up in the morning, we don't have disinfection things, we do not have masks, we have nothing. Afterwards, we woke up in the war where Russians invaded Kiev. And, I mean, they wanted to invade Kiev and invaded Ukraine. And we understood that, look, our European defense spending was not there, ammunition was not there, drones were not there, soldiers were not there. Actually, what do we have? We had a dream, what Francis Fukuyama was telling about the victory of liberal world order, but victory was not there. So now, clearly, we have to pick up on something which we have been neglecting for decades. And what are the major challenges, in my view, currently for our societies? And I have been speaking about that also in some other occasions. I would say one of the challenges is that the world is transforming faster than people transform. Technology is there, people are still not there. And if I have to put in the details what is a challenge for our societies, one is technological revolution, artificial intelligence. Americans compete with Chinese. Does Europeans compete with Americans or Chinese? We are competing how to unscrew the bottle of water in European Parliament. We spend hours, days, weeks, months for such decisions. They're, of course, extremely relevant. They're beautiful, okay, but I mean, who will lead these drones? So this is technological revolution with artificial intelligence and other things. Secondly, we have a communication revolution. The problem is that we have all the platforms on the internet. Well, I speak, you film, you transfer this, artificial intelligence is translating. But what is a side effect? I was lately, and Chris did not tell this, but Latvians here probably in the audience know, I am a very direct speaker. Not everybody likes that because not everybody likes the truth immediately on the stage. But you know, OECD have been making kind of research about how the younger generations are developing, how the education system is adapting. And I was giving presentation in one of the schools in one of the Latvian cities. I told, congratulations, younger generation Z. You are winners and you are champions in one thing in developed countries, not other regions, but in developed countries. Does anybody know what is that? Where are champions?
Anybody?
It's the first time in human history that generation, because of the modern technologies, are more stupid than previous generation. That is a fact.
You mean the PISA scores or what?
It's a score. They are down. They are less knowledgeable than previous generation.
Okay.
At the same time, you have a challenge where you need exactly that knowledge. So this is the second one. And then, of course, the third is kind of political networks, the surface, like international organizations, World Trade Organization, Health Organization, EU and NATO, and just name it. They do not correspond anymore to those challenges which we are facing in this very speedy developments in the world, and we can see this.
So if you could be king, what do you want?
Well, first of all, I admire those Romans who take kingship only for a very short, brief period of time and then leave again for their houses to do something at home. Like, I'm not anymore in politics now.
Right.
I don't feel responsible. But I would say that the most important thing are people. We have to change mindset. Because we can get technologies, we can win something, but we must make people understand in European continent that the water is very close to our mouth. The Russian aggression, no matter will there be Putin or will he drink tea or fall out of window, he will be there, and we must find a solution how Europe in defense sector, together with industry, can defend our continent without support from outside. It doesn't mean we don't need transatlantic relationship. We do need, we have to cherish that, we have to work for that. But we must be kind of self-sustainable. That's one thing. Can I give a joke, or you have any other questions? Or
I have plenty of other questions, but go ahead, tell us a joke. That's good. We'll break
look,
them.
you know, now, as you know, many politicians, it's not actually a joke, it's very deadly serious, you know.
Okay.
But many politicians are looking for different solutions, how to define and how to find the solutions for current security crisis. And security is one of the most important aspects for people. So technology, drone productions, drone alliance, European, Ukraine, so. I had another idea also some years ago when I was a defense minister. Just like Trump today, I was visiting China. And you know, in China, of course, there is a very nice reception always, and a part of great food, you also have great drinks. And I was sitting with a number of generals, and we did that pleasant thing, alcohol.
Chinese generals, just Chinese generals.
Just Chinese generals, and me with Latvian delegation. And one day, one moment, I thought, okay, now we are ready for a small joke. And I thought, look, I think as a defense minister, I will suggest that we declare war against you. They were kind of looking when everything was pleasant before. Why this guy, crazy guy from Latvia, wants to engage in a war with China? And I thought, look, if we start a war with you, or at least declare, your armies would have to cross Russia twice. And that was okay. They did not throw me out of a country, but that works. So that's one of the solutions. Go on.
Right, right. So with all this in mind, including having to cross Russia twice, how is Deep Tech and those who are attending, how do they fit into how we respond to this new defense architecture that has to develop, where we show much more resolve in preparing our own defense industry and defense for the unthinkable?
The only success what we can figure out and believe in is if we have three groups of people working hand in hand daily together. One part is a government, defense, army, that's all what is state. The second is industry, which I represent now. These guys, from small drones to big ones, and all other things. And the third is innovators, scientists, which means universities, schools, etc. And if these three groups of people would work hand in hand, and not just one after another or separately, I think we can answer the questions timely, because time matters. Time is the only currency about which you do not know how much is left in your pocket. So either it is your life or it is your business. Care about time. And I met here people, you know, just while I was waiting for this nice talk with Chris. And people were coming to me also from some startups and telling, look, I have sent this proposal or letter to that ministry or to this place like 3 years ago. They did not get an answer. I mean, because I understand bureaucracy is busy with their planning and etc. But this is where you have to work hand in hand. This is the only way. And this is why also we have our association, because we want to push those people in the corner, those who are not working and dealing, not because they are bad people, but we have to do the first things first, not corks on water bottles, but drones first.
Right, and you have this association of drone manufacturers, right? And you
yes, producers, Latvian and also foreign. So if there are any foreign producers who want to engage in this occasion, please use Deep Tech, use any occasion, join us. And I think the Deep Tech is exactly the place where you have to come together, you have to show what you can, what you want to do, believe your dreams and pursue them and look for partners here, because partners are just around, just like you standing maybe lonely either on the stage or there, but they are there to work with you together.
And say I'm a startup, I'm sure there are startups out there. What advice would you have them? I know there are a lot of things you could talk about finance, bureaucracy, procurement, things like that. What a couple of tips you might give to a startup?
Well, first of all, we know already from our surveys that there are three problems, and they are not just problems in Latvia, there are problems in many other countries, especially for those companies involved in military or semi-military or dual-use technologies.
Right.
So the first thing is investment, money, because you can come as a startup with a great idea, but then bank guys, they
Yeah.
tell, okay, but do you have any deals? Do you know what will happen to
And
you in
how
a
do you-
year or two? And you cannot get money. So we need to get a support, maybe with a support of either private people or with the government for the initial seed money and then afterwards for the scaling up.
To scale up.
The second thing is, of course, procurement, because defense industry is dependent on state procurement, because we are not going to Riga central market and we are not selling potatoes. We sell something which is under the restrictive rules. We also cannot just export like this to any country.
Yeah.
And the
Export
third
control.
thing is, of course, bureaucracy. There's no country where you have too less bureaucracy, so we simply have to figure out. And not the people. People are not guilty, not those who are working in state offices, but those paper keeps. We have to burn them. Sorry,
Yeah.
that's it.
Okay, it's a reality. What about tech sovereignty and the fact that the Baltics are a strategic reference point for tech sovereignty?
Well, we are. I think we are. Even if our public would complain, and I would complain too, we can improve a lot of things in our country. But as Estonian president, in this case, our neighboring country, Lennart Meri once told, we are like a small kayak in a sea. We can turn much faster around and we can see the things which will happen faster and we can adapt to this. So this is what is really our greatest perspective. So if the bigger companies in Europe, Airbus, Leonardo, doesn't matter which, in any country, if they couple with the smaller Baltic and Latvian companies, and of course with Latvian because we are the ones which started drones first
Right.
in the regions. We have the most drone companies actually in Latvia currently. If they are merging together, then I think we can get the speed, agility, and also of course the experience and heaviness of this bigger companies.
Yeah, and I guess when you talk about tech sovereignty, I guess the context might be, well, does that mean that we shut out foreign companies? No, we need that collaboration.
Not at
don't
all.
we? There's an example of a Latvian drone company bought by an American company. Right?
Yes, now it's called Redwire because this is the greatest, I think, invention of Latvian biggest drone companies, Redwire. It was Edge Autonomy before and it was UAV before, but it is totally invented by Latvian engineers, by Latvian business people. They got so successful that Americans simply thought they have to buy it. There is no such company somewhere else in the region which is producing such type of drones.
Yeah.
Another example, maybe you do not know, but there is a company, Pērkons, which is also a member of our association. They are producing batteries for all types of drones. They are developing extremely fast, but there is no other such battery producer in Europe in the closer than 500 kilometers to Latvian borders.
Yeah.
Nobody.
Yeah, right. NATO. There's a NATO summit coming up. As a former defense minister, what in your Dreamo vision would you like to see, or your Dreamo nightwears?
Well, I remember my
Nazi.
last NATO summit in Madrid, but that will take too many minutes to tell what I did there. But I would say that I look to the prospective NATO summit in Ankara with big concern, because I think that we as friends and members in Alliance, in the last year or last year and a half, we have been really neglecting each other. We have been punishing our closest people, our closest allies. And I think that at the end, if we look to the global competition, then here, European continent and transatlantic alliance is of the greatest value what we can have. And if we will neglect that, and if we will blow up something in Ankara summit, then we will lose global competition.
But how do you see that with this new European defense architecture we want to build? Is it contradictory, or what? How do you?
Not at all. Not at all, because look, I mean, the sum of our security depends of each and every of our individuals. If Latvia can pay 5% for their defense, if they can invest in their technologies, so should others do. And if I look to our Western European partners, sorry guys, if you are here, I mean, speak to your public and don't hide as a politicians, for instance, behind the people and crowd. Be leaders on front of them and lead them somewhere, because these things, the small ones, They don't fly anymore only across the Latvian borders. They can be in Paris, Madrid, London, and Rome, and you will even not notice them. So if you have imagined security, then remember it's just imagination. You are less safe than you think.
Final message to deep tech, to all of us here?
Well, I would say that I first of all would like to speak with innovators, everybody who is working on this in their place, because each of us have to do our job where we are standing. And I would refer maybe to the initial example and question about drone Lima in 1998. And I would say there are three things perhaps which we should take into account. I would say time. We never have too much time, so you have to be speedy. Just like in a front line. Speed, this is one of the differences which changed the current warfare in Ukraine under the Russian invasion. The second is courage, because there will be a lot of cases, and I faced myself such issues where you have a great idea, you dreamt it maybe on Sunday or something, and you want to implement, and then you have three people in front of you telling, no, you cannot do this. Because of that, because of the bureaucracy, don't listen to them. Do it. You will fail first time, you will fail second, the third, you will succeed.
That's how you
because
learn.
people learn not from victories. Victories make us lazy. We learn from defeats. Get defeated and you will be happy and lucky. And the third usual classical thing, which we cannot influence, but this is just a fortune or luck. We must be also sometimes lucky, because we can do everything correct. But if the luck is missing, we have to have again the right timing.
And this is not your first deep tech. This is your second.
Yeah,
Why do you come back?
I came back because probably I did not fail totally on the stage last time, and they didn't invite me.
Is that why?
Yes. I mean, connections and people, that's what matters. And this is why deep tech is here. And if you miss these connections, if you miss people, if you sit on Instagram, you will be like Generation Z, you know. So take the best thing. You can be technologically advanced as a young generation, but get smarter than previous one.
and tap this guy's brain. You're around a little bit today, right? You be around?
Yes, I'll be here.
So come to Artis, right?
If you need me.
You do.
And remember, Miltech Latvia, join it.
Big hand to Artis Pabriks. Thank you.
I don't leave this here.
And thanks to your drone.
We
gonna
fly
it out?
home.
You're going to fly it out?
I will fly back first.
Okay, all right. Thanks, Artis. Thank you so much. Big hand. That was great. Let's, we were talking about stepping up potential, upscaling. We want to talk about that now, about autonomous systems, drone superpower ambitions, and remote control. We're talking about mass production in defense, how Europe can produce at an industrial scale. We got a lot of ideas here, a lot of ideas in the Baltic Tigers, but what about scaling up? Let's talk to Frédéric Montagnard, who is co-founder and president of Alveum, which let's explain later in a minute what that means. Defense sector experts as an interface between innovation, industry, military, and finance. Frédéric, please. Bonjour. Bienvenue.
Thank you, Chris.
Yes.
Thank you so much.
Welcome.
How impressive it is to go after a minister.
Easy, no problem.
I too brought some hardware. Can you see?
There you go. Show and tell. We have to have show and tell. It's important. Before we get to that, this Alveum,
Yep.
which means watering hole, right? In Latin, right?
In Latin, right?
Can you explain that? Why is your company named Alveum?
Yes. Hello, everybody, and thank you, Latvia, for this invitation. I created Alveum 2.5 years ago after quite 30 years in aeronautic space and defense in a big European prime. And I discovered that things are not easy between innovators that are in this room, big corporates, also probably in this room, operational people, like people on the front line, military people, and also investors. So alveum means the watering pot in Latin, and because in Africa, the prey and the predators, they don't attack each other at the watering hole because they are all interested that they have children and grandchildren and that this continues. So we all need the others, but sometimes we are in a fragmented world.
Yeah.
We work in silo mode, and I'm trying and helping to make these people
So
of different origins
So
work together.
it's about collaboration, trying
Yeah,
to
exactly.
motivate and
That's it.
collaborate.
That's it.
And before you get to your presentation,
Yes.
you have a couple of show and tell. Or is that part of
Yes.
the presentation?
Yes. If you agree, I will explain at the end, if
Okay.
it's fine with you.
Très bien. I leave it to you. Okay.
The minister showed a drone on stage, and I have some hardware as well, and I will explain you why. But maybe I will first start with saying why I am here for. I took some notes, and I want to give some words to you. To me, Europe is entering a strategic partnership paradigm shift. The challenge is no longer simply producing faster, but rebuilding stock depth, resilience, and long-term industrial sustainment capacity. Missiles, drones, electronic warfare, spare parts, critical components, and munitions all face the same reality. Europe must move from a flow-based logic, I think I have a slide on it, yeah, from a flow-based logic to a stockpile and regeneration-based industrial model. The other question now sits further down the line: structured European joint ventures, cross-border industrial integration. Europe-Ukraine cooperation in combat-proven technologies and the ability to scale complete systems and critical systems simultaneously. Money is not a constraint. Industrial depth, supply chains, and scalable manufacturing capacity are. So in a nutshell, and I have 3 slides, I'm not like the minister, I'm not so, I would say, easy on speaking without notes. I wanted to show that it's not about speeding up the production. It's also rebuilding, stockpiling, and regenerating the stocks. This is the logic. And this is why we have also some components and not only the subsystem that the minister just showed before. In terms of cooperation, of course, as it was said before, one company, one startup cannot have all technologies. So we need to cooperate. We need to cooperate between companies, but also between countries. That's where some joint ventures can be used. The most powerful missile company that you know is called MBDA in Europe. This is a joint venture. You probably know that better than I do. We also need to work with Ukraine because this is a combat-proven technology, and as well as the quick fail-fast operational feedback and the capacity to have massive productions. And the battle is industrial. Of course, what is happening between Ukraine and Russia shows that this is all Europe should be behind Ukraine to have the depth, the industrial depth that the Ukrainians battlefield needs. And the scalable production volumes, where will it be? It will be at component level. It will not be at drone level. Maybe you will have some Latvian drones, you will have some Lithuanian drones, you will have Estonian drones, but maybe the components can be European components. And that's, of course, a bigger market, a bigger volume, and, of course, a lower price, because it all deals with the capacity to produce and to mass produce massively. And one last word. Some activities are decreasing in Europe. I speak about automotive. I speak about other, I would say, declining industries. There is a way also to use these industrial capacities that are maybe a little bit under operated for our defense production. So that's what I wanted to share with you. And I brought with me some examples. And maybe, Chris, you want me to
No,
tell
please.
you.
Let's do the show and tell, and then yeah.
Okay.
Sure.
So this is for a drone. This is for a chassis or for a board of a drone. Does anyone in this room knows with which crap, waste it is made of?
Anybody?
Very light. Can you check?
Yep. Very light. Yeah.
Any idea? It's made of cork. Of course, it is a cork that has been sintered, that has been
Yeah,
pressurized,
it's very dense.
very dense,
Doesn't feel like cork.
but it's very light. It's a chassis for drones. I have brought with me something from ballistic protection. This is European technology. It's very light. I think Chris, you can also confirm to the audience that it's very light.
It is.
It is able to block a Dragunov. Do some people in the room know what is a Dragunov, which is the bullet of the Russian sniper rifle, which is the fastest bullet in the world.
It's very thin, and it can stop that.
Exactly, and
Really?
it's very thin because you can protect lives, you
Yeah.
can protect vehicles, you can protect helicopters' floors.
It's
So-
definitely lighter than Kevlar, right? Kevlar is a lot
Lighter than
heavier.
Kevlar, and
Yeah.
because you have some kind of a square, if you have a hit, you just replace the one that has been hit, not the whole floor, not the whole ceiling or the wall.
Right, much more efficient then.
So that's it is European manufactured. It is the lightest and the strongest in the world. We do have technologies in Europe that are able to withstand. And the last one I brought with you, which is the only one that I would say the French custom and European custom allowed me to bring to you. I have other things to show, but unfortunately I couldn't take the flight with. Is 26 gram. It's a radio link.
Right.
It's for drones. It is currently designed in Ukraine with on the battlefield. I mean, with the Russian jammers permanently
Really?
trying to tackle it. It can be used up to 35 kilometers. It is currently manufactured in Asia. And guess what? This month the production is starting in Latvia. Here.
Starting here.
In Latvia. And the price, the target price, is 10 times lower than the competition. So we are able to mass produce in Europe at a comparable price to China our own battlefield-proven technologies.
And this is produced in one of these micro factories, dual use. Is that what you're talking about?
This one will be produced in a traditional factory,
yeah.
but not this one, but we could produce this in a micro factory.
In a micro
Yeah,
factory.
that's it. Yeah.
Right. And that could be anywhere in Europe. That could be, right?
Exactly. Yeah, and we can do that in somewhere else. So just to say that, some French people, because you know that I'm French, due to my accent, some
Mais c'est
French
très
people...
charmant. He's very charmant.
Very charmant.
yes.
So some French people, like my president, we are speaking and about what we will do, and we never do that. So here we have no time for that. So we do the stuff, and then maybe we are here on stage and we can discuss with you. But we only speak about what we have done and never about what we will do anyway if we have some budget also. So that was kind of, I would say, spirit of work.
Yeah. I mean, the spirit of collaboration. I just want to mention that you just came fresh off Dymex, right?
Yeah, exactly.
Dymex Baltic 2026. That's the first ever international defense and aerospace industry meeting and exposition in the Baltic. What's the significance of that for you?
It was so impressive. The representative, the Lithuanian president of the Republic was here. The minister were there. It was unbelievable. There were people from the whole world. It was a dedicated dual-use and defense summit. Yesterday, there were some testing in a military polygon. So it's not only talks, it is also testing, real testing on the field. So the conjunction of this high-level discussion that we can have here in Latvia together with the testing is so impressive. And I think in Latvia, there will be, in 2 weeks, there will be a drone summit here in Riga, and there will be some testing from NATO the day before on the 26th. So if some people in the room are invited and are interested, it's nearby Riga. It's probably 60 kilometers from Riga.
How much synergy do you see between the Baltics and the French defense industry, for instance?
I mean, we need to cooperate.
Yeah.
We need to cooperate.
It's not there yet. It's not enough.
We need to cooperate. We need to produce We need to produce. There is tech here that we don't have. We have tech that maybe we can produce here.
Right.
The first market is, of course, to support Ukraine. This is clear. This is a massive market. I mean, probably this year, 10 million drones will be used. Last year, it was 6 million, if you know the figure. But of course, what is at stake is then to protect our democracies. We do need drones, of course, maybe to balance with Russia and its allies like Belarus, but also we need drones for countering drones. We need interceptor drones. We need to protect. So the market is huge, and probably there is room for anybody. What is at stake is production. We need production.
What's holding this up? Is it changing minds, as Atis was talking about, or what? Is it more on the French side, or is it on the Latvian side, or what?
I mean, it's
to get that cooperation, to get that working together.
It's where it fits better. I mean, we have some capacities of production because of our automotive industry is down, especially in Western Europe, like in Germany and France. Yeah. So we have some capacities of production. There is some capacities of production up here. The cost is lower in some areas as well, so it has to be taken into account. But I believe that this is more like a triangle. There should be a target, and today is support to Ukraine, if you agree. And then it can be a combination of several countries, joint ventures on an ad hoc basis. This is what I truly believe. I hope I conveyed this message to you.
Any final word, Frédéric? I think we're good at this point. We got a minute left.
Yes, maybe just maybe in a nutshell, I was in innovation for years, and all the time the blocking point was the scaling up. The scale up. I mean, POC, proof of concept, is easy, but scaling up is difficult. For scaling up, you need orders. To need orders, you need capacities. You will not get order if you don't have any capacity to produce. To have capacities, you need money. How do you get money? You get orders. So it's kind of a vicious circle.
Right.
We need probably, if you agree, we need to reverse. If we have identified production capacities, we can convince the customers and we can convince the investors that we will have the capacity to deliver. Capacity to deliver will ease the flow of money from Europe, from customers, and from the investors. And so I believe this is all the way around.
Very good. Frédéric, are you around today a little bit so people can connect with you? So this isn't the end. You can tap Frédéric's expertise. A big hand to Frédéric Montagard, please.
Thank you. Thank you.
Merci beaucoup. Hein?
Merci.
À la prochaine.
Merci.
Great. Wonderful. Let us move on, yes, to what about when seconds matter? Are cities ready for drones, 5G, and artificial intelligence in public safety? I am going to pass the torch for this panel to Viestur Selmins. Did I say that right? Viestur Selmins. Welcome. Big hand to Viestur. I guess I pass it off to you.
Absolutely.
Right?
We're on.
Yep.
Excellent. This is a rare case where you start to talk about drones and you don't have from scratch. People have been paving the floor for discussion here for a couple of hours, which is excellent. Scaling. We're going to be talking about drones are ready. This is clear. But the city is ready. When you deal with battlefield, when you deal with remote areas, drones is one operation. When you deal with cities, dense environments, a whole different ballgame. This is going to be the order, the framework, and architecture for our conversation to follow for the next about 45 minutes. We'll have two stages. We'll have what we call the helicopter view of where we are with 5G, with civil protection, with docking, and security in the network. And the second section will be dedicated to us discussing the matters where we're hopefully going to be getting questions and inquiries from you. In other words, we're shifting gears, still drones, still airspace, but now with the city space, which is a little more difficult. Again, we're building roads, same we're building roads now in a city, we're building roads up in a city, which is rather quite different if you do that above the fields or woods. Okay, without further ado, my name is Viestur Selmins. Thanks to Chris for pronouncing my name right. I usually call Mr. V or Victor for convenience sake. Now I get my full name pronounced, which is excellent. we're going to have, again, fantastic presentations, which will lead into the panel and feed the panel as we go forward. So let me introduce the panelists who will be sitting here with us for the next 45 minutes, and we'll be presenting and discussing. So let me first start with Gins Jacobels, LMD, working on 5G provision, AI computer vision. Round of applause for Gins. Lauris Labanovskis from ECHO, making sure the frequencies are right and we have right signal going on. Thank you. Round of applause. Ilan Platonov, Riga Digital Agency, working on civil protection in terms of safety for police. Round of applause. I have only one hand, you have to help me. Kristaps Nedos, Riga City Council, on regarding the drone safety and docking in the cities. Round of applause. My name is Vestor Selmic. I'll be moderating and making sure that you have your questions answered in due course. Right, without further ado, we're going to have, for the next 15 minutes, more or less, we're going to have 3 presentations which cover the ground, what we've been doing in the framework of 5G for Lives, a project which is financed by European Commission, because this is an important area, again, for cities, and this is where the name on the TIM comes from. We're using drones to make sure that we are gathering intelligence and especially making sure that the pilots pave the way for compliance in terms of saving lives in the waterways and the water reservoirs. So that's going to be the framework for our conversation, but we'll be looking also in deep dive in computer vision, compliance, technology, and especially the working culture, which I think is the biggest issue. Again, if you take one thing away, the drones are ready. Is the culture in our institutions, especially in the public sector, which have quite a few things to catch up. Right, so without further ado, let me introduce our first speaker. Again, 5 minutes for 3 of them, and then we're going to proceed to the panel. Our first presentation will be by Gins Jacobels for LMT, focusing on public safety and computer vision. Round of applause. Gins, the floor is yours.
Sure. Thank you. So, I would like to start with a quick challenge. Here you can see a swinging area, lots of people, lots of movement. Now, without counting out loud, try to estimate how many people do you see here. Hard, right? Not so easy. Now, let's take the same scene, just add on top of it the AI layer or computer vision layer. And instant feedback, instant counting, 0 effort. So this is the kind of challenges rescue services struggle daily. So computer vision can help with this. Of course, during the project, we also looked at the possibility how those technologies work in different environments, not only the summer, which is quite easy, but also in winter, in rain, in snow, in everything. So this particular example is from ice fishing, fishermen who are sitting on an ice, and sometimes it's very dangerous when spring comes, they are still going for the fish, even if there is potential of danger. And this, again, gives additional problems for rescuers, because, of course, they need to have everyone on safe side. The 5G for Lives project, goal of the 5G for Lives project is very simple. Use the best new technologies, combine them, and save lives. So what we did, we combined 5G network, computer vision, sensors, and drones together to achieve this goal. And most often I get the question, why mobile network for drones? And for me, it's a clear answer. The beyond visual line of sight flights isn't possible without good communication. And mobile network is a wide area, stable and low latency solution. Wi-Fi can't do it. Radio links can't scale. Mobile network, 5G, can do it all. And during our project, we're not just sitting in the labs. We really done something in real life. We implemented and equipped our existing base stations with 5G standalone technologies so that it can be tested during the drone flights, during data transfer, and see how it's working all together. And I will dare to say that we are one of the first mobile operators who have done it in real-life scenario. And in conclusion, I would like to say that you can have multiple user scenarios like search and rescue, environmental monitoring, or public safety, but they all cannot be served with one technology. You need to combine. And in our case, we done it together with drones, together with mobile network, together with sensors and computer vision. And this is what we achieved in 5G for Lives project. So we combined all those technologies in one ecosystem and brought it to the life. So thank you.
Thank you, Gins. All right, so we're moving on. I'm going to be standing, I think, on a side here rather than sitting in front of everybody. We're moving on. If Gins left us with a notion that for the system to work, each part has to do its own job in the same way as orchestra. Our next presenter, Lauris from Echo, will be covering the ground. How do we make sure that the network is stable? How do we make sure that the measurements we get on the network are safe and reliable for drones? Why I'm asking that? Obviously, if the drone comes down, we're in trouble. If it comes in a city, we're in big trouble. Same way as it happened with the AI autonomous systems elsewhere. If they come down, the industry is taken back for years. So this is the biggest issue. We want to make sure that the network is stable. Over to you, Lauris.
Okay, my name is Lauris Labnauskis, as it was said, and today I will briefly explain how we can check if 5G networks are ready to support real drone operations. In project 5G for Lives, we developed a practical measurement methodology. So the main idea is simple. Before using drones, 5G, and AI for public safety, we must know, does the 5G network really works in the air, not only on the ground? So mainly, mobile networks are designed so that they provide coverage on the ground. But the drones are flying above the ground. At altitude, radio environment changes. And drones may see much more base stations simultaneously, which can create co-channel interference. Also, antennas, a lot of antennas are tilted downwards so that they provide good coverage on the ground level. So good ground coverage does not automatically mean good coverage in the air. So we have to understand it. And this is why real-world drone-based measurements are needed. The mobile spectrum looks large, but for the drone use, freely available spectrum is only, let's say, a small part. There are technical and regulatory limitations, especially near airports, radars, other protected systems. So 5G spectrum does not automatically mean that every drone mission is possible. Each mission still needs careful planning. In our methodology, we measure 5G performance in two complementary ways. First, idle coverage, whether the network is visible and available. And second is connected performance. What happens when drone connects to the network in the air? Here we are looking to the more practical KPIs like data throughput, latency, data packet loss. So coverage alone is not enough. We need to know if the network can support the real service in the air. Public safety use cases need stable and predictable connectivity. If a drone sends video, sensor data, information for AI analysis, radio signal quality becomes critical. In our measurements, signal strength was normally stable, but signal to interference ratio was more sensitive to the interference from the distant base stations. So the key question is not, is here a coverage? But the better question is the radio signal quality good enough for that mission? Mm-hmm. The goal is to create a practical and repeatable methodology. It helps to find weak spots, to test the real performance of the mobile network, and to support better planning of the drone corridors. This work was developed in 5G for Lives project, and it was done with real UAV measurements, which we done with our equipment. Latvia submitted this material to CPT organization, European organization, and it has now become an official work item. Actually, they are going to complete the work within this year. This is a step toward a common European approach to the safer drone integration. So to conclude, the signal defines the mission. If we want drones, 5G, and AI solutions to become a real public safety tools, so we need evidence. So assumptions is not enough. Ground coverage, mobile network coverage, is not enough. Good demonstration also is not good enough. We need airspace measurements, clear KPIs, and a common methodology to do that. So only then can we say that a drone-supported 5G solution is ready to serve for the public safety operations. So briefly, that's it. Thank you.
Thank you, Lauris. Our next presentation will be where will the drones be parked? Give us 5-7 years. Hopefully, Police of Riga, Police of Liepāja has drones in their fleet using the airspace for what we call the Bay Watch, to be honest. Perhaps not so sexy, but more safe and more secure, having eyes on the ground, watching those 80 people as they move around, either in summer or in winter. So that's the back end to front end make work. So Kristaps, over to you regarding the parking spots for drones and the GIS tool that City of Riga has developed. Over to you.
Great. Thank you. So I'm representing the City of Riga, specifically the City Development Department, and like Victor said, I'll talk a little bit about our Baywatch, like you said. Yeah. So in 2023, we started a project. We joined a project funded by the Interreg Baltic Sea region, EU funding. It was called City AM, which basically focused on equipping cities to integrating sustainable urban air mobility. We had a 13-partner consortium from 6 countries. We had Stockholm, Helsinki, Hamburg, Tartu, Riga, and Gdansk, and plus a lot of different associated partners. From Riga's side, we had our city council as well as RTU. It was a 3.7 million project. It went and finished last year. So one of the tools we developed was drone takeoff landing site GIS planning tool. This is how it looked in its initial stages, and the whole concept is that you would take different data layers to go through and see where are the potential landing and launch sites for drones, and it just gives you an overview in like a traffic light setup, where green is the most preferred, and red obviously is somewhere where you don't want to put any infrastructure in. So if we take a use case, how it would look is a drone operator would come up with an idea. Say you want to deliver food, you want to
deliver blood from different hospitals or whatever. You come with this idea to the city where you talk with an urban planner, air mobility planner, you talk with the CAA representative for the country, as well as your GIS expert. You come up with a list of locations that you would potentially want to use. Then just the urban air mobility planner with the operator, in this case, would go through the list, see, okay, these locations are the most fitting, these are not so much. And then you would go and actually make a short list and inspect the locations in real life, because you never know, like, a GIS tool is just a decision assistance tool, so you never know how it actually would look in real life. So you go, you validate, you talk with your local residents, and you see maybe there's a big opposition to that or not. So you just go through that, you come back to the city, you talk over, you see, okay, these are the 3 final locations that you want to do your service from, and then the urban air mobility planner just takes that and starts the process where maybe it's a government property, you need to then rent it out, lease it, or however the legislative process is. And using that tool, this is an example from Riga Technical University's campus, where you see, say, the green areas are potential locations where you could have launch and landing sites put in. Some of them are rooftops, some of them are just like green areas. And whereas the orangey areas is not preferred to have drone sites. After that, our partners at Riga Technical University, they took the projects tool and made it a step further, putting in more precise data layers and public spaces to see, okay, how could we actually do it? And the blue line actually means a potential drone route if taking account in all of these exclusion areas and restriction areas. This is how a drone could potentially fly between universities. And out of the GIS tool, this is an example of how the analysis could look, where taking a part of Riga city, you see the green areas, the orange, the red areas, and this, in specific case, it gave us information that there are 228 potential launch and landing sites in this area of the city. 368 of those areas are risk areas, so kindergartens, schools, and different places where maybe you can find a place to land or launch, but it's not really preferred. And then 69 restricted areas where children's playgrounds or other high-risk areas where you would not want to have drones landing or flying. And so, what's next? Project's ended, everybody's happy, we showed off, but we're actually taking a step further. We have our GeoRiga website where we're currently already in the process of integrating this planning tool for urban planners internally in the city to start helping out potential drone operators, and as well we're working on a thematic map to then post online so people can just take a look and see how it goes. So that's all for me. Thank you.
Excellent, Kristaps. Thank you so much. We're going to be taking our seats for the next 35 minutes or so. 2 notes of hygiene for us to work together. We'll try to make sure that our answers are brief and on point. The second point of hygiene is we'd love to have your questions and inputs. I think my eyesight is okay, but I'm a little blurry, so if I'm looking at you, it's not because I can't see you, because generally everything is a little foggy there. So please raise your hand, or perhaps even stand and ask a question regarding the areas we have. I think we have the whole ecosystem covered here. The end user, the city, Ilona, we have the city with the GIS tool, we have the signal people to make sure they're up in the air, we're safe and sound, and we have computer vision, which is giving us the big capacity here. So without further ado, let's crack on. Ilona, let's start with the main front-end component. From the orchestra we mentioned, the 5G, the AI, computer vision, the signal, what are the things that municipalities are anticipating the most or waiting the most for?
Well, first I have to notice that we, as a Riga Digital Agency, have a mission statement. And in the mission statement, we want to make Riga be the most advanced city in the Baltics in terms of use of digital technologies. So we are already using a lot of drones and for different use cases, which are already necessary for our people. But there's one thing, our budget compared to, for example, Finland's Helsinki budget is 10 times less for the investment.
We have the brains, though.
Sorry?
We have the brains.
Yeah. And we have possibility to test new technologies even if we don't have that much funding. So we aim to develop new technologies in Riga, otherwise we can't reach that aim. And this is one part of our job, just one of the projects.
So at the moment, we are at the scaling stage, and we want to mature the solutions and grow them into existing fleets and with the city.
Both. We want to test new solutions because it may be that some of them do not work as we intend.
Okay,
But
we'll get
we
to
want
that.
to be developers.
Gins, over to you. So what we saw is obviously a game changer. If we can actually have that kind of fleet up in the air to make sure we monitor, that would be a game changer for what we call the monitoring for police. But what's the gap that we have to bridge between where we are and where we want to go?
Well, I think the main gap is that what we need to have is that we now done some demonstrations, and it's in good weather, one-time demonstration, and that's it. But we need to have a step forward towards everyday operations, and I think this is the biggest gap that we are having, from demonstrations going towards real-life operations.
So to use the analogy from society, we need the 10,000 hours. We have a couple of thousand perhaps, and we need 8,000 more before we get to excellency.
I would say so, because in demonstrations we see that each technology is working great, but on daily basis probably there will be some additional issues that came out that we cannot have from one flight or one demonstration.
Okay, proof's in the pudding. Lauris, moving on, what do you think are the biggest misconceptions or shortcomings how we see the network and reliability?
So I think that the biggest misconception actually is that good 5G network coverage equals reliability. I think in this case it's not. So coverage is necessary, of course, it's not a question. But for reliability, it's necessary much more. So in general, I think that reliability means that when a drone supported a 5G system, so that drone can operate safely and predictably, not even in ideal conditions, but also in conditions when signal becomes weaker, latency is
Due to nature or interference.
Yeah. So even in harsh conditions, it still works predictably and safely. So because not only everything depends on the mobile network, a lot of things depends on the drone itself, from the connection module between the network and so on, uplink performance, and a lot of elements which together create reliability of the end solution.
And for us to arrive there, to get the reliability up and secure and stable, we just need more airtime, basically, to make sure that the network is not jeopardized in any of those capacities. Is that correct?
Generally, yes, but to check how the network performs, so we have to perform a lot of measurements actually. Before deploying the technology, we have to understand does the network provide necessary performance? Is it stable enough? Where are weak spots to change something in the network and so on? So it's a big job before that.
Excellent. Back to Ilona, regarding the city. City is the end client, the front end, where we actually need a service. This is a lot of backstage work that needs to happen, needs to be secure and reliable and smooth. Again, the 10,000 hours of airtime and airspace time. What are the areas where you think that if those things would be working in sync as an orchestra, harmonized, what would be the best areas where we could see the most benefit, the biggest yield and dividend from these technologies?
Right now, we of course have aimed at saving people's lives, but luckily we don't lose too many lives, at least in the areas which we make secure. But there is a lot of resource efficiency issues as well. When we ask the team to go with a boat it takes a lot of energy, while we could send a drone and take a look at how things are there.
In the case of
without.
emergency.
Not even in case of emergency. Actually, we patrol a lot.
Okay.
For example, we have a safety area around Čižezers, people who live in Latvia know, which is a locked place where we would not like to have people during bird nesting time in the spring. And how can we make sure that there are no people crossing that line? We have to go there by car and actually cross the line ourselves. Now the drone with specific camera, with a thermal camera, can identify people if they are there in that area. And only then we intervene, without just spending time and police resources to go there to damage the wooden roads and so on. It sounds like maybe not so important, but actually for the city, the ecosystem is very important to maintain it in the best possible
And
area.
so there'll be improved precision in terms of what's happening where. Number two would improve efficiency, so people don't have to go out there with boats or whatever
And
they're
also
using.
react faster.
Okay, okay. Excellent. Over to Gins. So I think you set the stage excellent there, where we showed, it took us a couple of seconds to even orient ourselves in the video you showed at the beginning. Where are we? We're in the shore. We're watching the people. Some are on the ground, some are in the water, some are docking on a platform there. So that's an area where clearly computer vision helps within seconds and can react in seconds with an emergency happening up. Where does the sort of human come into that conversation? Can humans even work with that amount of data? Can they cipher through it fast enough?
In my opinion, all those technologies are like tools that humans can use. So human will be always in a loop, in my opinion, at least for a couple of few next years. And humans will make decisions based on information that they get from all those.
So in that scenario, there will be a red alert coming from a certain geography in our screen and saying, well, this person is in distress. And then you have to make a decision upon that. Is that correct?
Yes, exactly. For example, as you mentioned this scenario, you will have an alert, then the responsible person will decide, okay, whether it's a real alert or fake alert. If real, then what next must come.
Which I would assume includes not only the training up in air, but training of the people that they're able to use the digital technologies fast enough and reliably enough as well.
Definitely.
Excellent. Moving on, Kristaps. So you did discuss the sort of what we call pilot graveyard. A lot of pilots, no scaling, which has been mentioned with the people before us as well. How do we move out of the pilot graveyard into some consistent service, which is something we all sort of want to desire in the city environment as well?
Yeah, I would say there are maybe two elements. One thing that just Gins touched on of, okay, somebody gets an alert and you see, okay, you have to react. I would classify it from like maybe a city's perspective as having some form of governance in place for the whole process. So knowing who's responsible, who does what, who handles the data, who actually then takes responsibility for a good decision, a bad decision, just that whole process. And to touch on your question about pilots and pilot graveyards, I think pilots in of itself are not a bad thing if you do a pilot not just for a pilot's sake, but actually look, okay, can we get some learnings out of it? Say our project that I mentioned, the City AM project that we did with our partners, there was a lot of actual drone flights taking place, and those were such a big learning. Say for Hamburg, in the port of Hamburg, they had a lot of beyond visual of sight flights where they had to go step by step through the SORA processes and a lot of different bureaucracy, but it was a great learning for everybody. So I think with pilots, I myself, I'm for them as long as they're leading to a solution. And of course, the solution or the goal is operational readiness for the whole city, is you try a pilot to then figure out a solution for a specific thing. So.
Excellent. So one thing I take away from your comment here is, first of all, with innovation, with a pilot, you finally see the entirety of the journey. How many steps are there? Who are responsible for each party, which department, or perhaps even just a whole section of municipality. So you see entire journey, first of all. Second of all, you see where we have friction between departments or the work log and responsibility as well. So for the next time, if we would scale that, I would assume we would gain some time and efficiency in terms of deployment.
Exactly. You know who to talk to, who to call, and so forth. Yeah.
Right. Lauris, you did mention just a second ago that the fact that something worked once during demonstration is good enough, but that's not sufficient. Necessary, but not sufficient. So what kind of evidence do we need to make sure that it's always there, it's always safe, it's always reliable? You know, we don't have to go through the entire checklist for the system to be working completely, with instance in police, and they're having the monitoring system in place.
Okay, I think the demo proves that the system worked once at specific conditions. But if we speak about the public safety, it's not enough. We need much more. So, and these things which we need are repeated measurements, real flight tests in the real life, clear KPIs, how we will measure, was it successful or not. So tests in the degraded conditions.
So when you say that, do you mean rain, snow,
also
storm?
Yeah, also weather conditions, also network conditions where the network connection maybe is not ideal.
Jamming, interference?
Probably, yes, also. I will come to that. And fallback procedures. And this is one of the, I think, one of the most important things. What will happen if you will lose connection? So fallback procedures must be embedded in that system so that it continue to act safely and predictably. It doesn't fall somewhere, it doesn't go away uncontrolled or something else. Yeah? And the key question is not did it work once, but the better question is does it work consistently?
10 out of 10.
Consistently and fail safely. So this is one of the most important things. Of course, we have to test it end to end in different conditions, different scenarios, and so on, and come to the conclusion. But the result is consistent operation and safe failing in case of something. Yeah.
I think it's an excellent point. I think that when we use the car or vehicle in the streets, we're used to getting a little bump or scrap or seeing cars crashing. That's something we are not expecting, we're not tolerating up in air. One drone gone astray may go into the area which is restricted, is going to push the whole industry back for months onwards. Same way if the drone falls down, God forbid, on somebody's head or near somebody, that pushes the whole industry back for months. That's happened before, and that is going to happen in the future unless we have the reliability in place. And I think that's a huge difference for us, that we are used to having car crashes all the time, every day in every city. That is something we can't allow, we can't tolerate up in the air. Zero tolerance for mistakes. Huge issue, especially in the civil sector, and especially in city environment, which puts industry on huge toes at all times. Moving on to Gins regarding the weak points. I think we're sort of in a critical area. Let's hope we move out in the sunny side of things, but still in the weak points that you think we need to account for and keep in mind once we want to scale and get out of pilots into systematic use of drones in our monitoring.
I would say so that every technology by itself works greatly, but the weak point is when we try to integrate them together, and then sometimes, I will not use my French, but can happen issues. And I think these are the main weak points when we try to integrate, for example, drones together with mobile network. What we saw also in this project, that it's not so easy, not so straightforward. We need to have both parties in place to see, okay, if drone is not working, is it a drone fault or a network fault? If network is not working, again, the same question. So I would say that the biggest weakness that we need to address is those integration points between all the ecosystem partners that are involved in.
Which obviously takes quite a bit of time.
Yes.
So the network and the drone and remote control, and then the filming and setting the signal, and then the police using the signal and using the feed to make sure and make decisions regarding their action, that's quite a lot to happen. Right? There's a lot of cooking to be taking place.
Whether all those systems are talking the same language. So this is very important.
And that's all has to happen before you make a decision regarding the seconds. Okay, moving on. a little bit around here.
Maybe I can add.
Okay, go ahead.
Because
Fantastic.
I feel that we are discussing about one particular pilot, but at the same time, we figured out that the drone ecosystem is changing completely. We all know that now we have some unidentified, unknown drones which just appear from somewhere, and actually they create.
We just lost the
threats.
government, by the way, if someone's missing that anecdote there.
that we would not even touch right now, because we first saw it in the airport. Now we have locked the airport area. We are trying to protect and have a system in place that we can get those drones down. But in the city, we cannot get those drones down, especially if they are flying under the heads of people. And so we are. Even though we started with the project with trying to test certain use cases, we actually had to buy extra equipment to identify those privately owned drones which appear, which sometimes ignore the whole regulation and the rules of where they are allowed to appear, how they should be led, and so on and so forth. And that's a major issue which has appeared only now. It was not an issue a couple of years ago when some people were just testing drones on the woods. Now they are really flying in terms of the city, and you all the time have to be sure that there is no breakage between them, and how we can find the owner, how we can address them, saying, guys, you're not allowed to fly when there's 10,000 people in the Meža Parks area.
Ilona, just to press you on that issue, you said the ecosystem has moved on from where we started 3 years ago. Obviously, you say that the ecosystem has moved now and the things are getting easier for the city of Riga to use this technology easier, so it's basically foolproof? No? Yes? Maybe?
Yes and no. It has become easier also for any other user
Right.
to obtain a drone. And the thing is that we still play on an assumption that all we are obeying the rules. And
I've
that's
heard
not
that,
the case.
I've heard that about 50% or more, anecdotal evidence here, obviously, are in airspace are illegal. Someone who is smarter than me. Can you confirm that? More than half of drones up in air are illegal. Is that correct? No? Yes? I've heard about 70 or 50% of the drones up in airspace are without permission to even be there. So I think that's quite of a chilling number. And obviously you can comment on that. Back to Lauris and Gins. So you both mentioned the coordination is a huge issue again, because this is an orchestra, if we can use that quote unquote analogy here. So the common methodology, if we are in a spectrum out of 1 is very bad and 10 is very good, where would you put that common methodology for testing to begin? Where are we right now? Who wants to go, Gins or Lauris? We have to have it. We need it. It's clear. Where are we with that?
I would say that in Europe itself, we are moving towards the right direction, because already like 5 years ago, we started negotiating together with other countries regarding what would be the measurements for the networks that must be in place for drone flights. And I think there is still a lot to do, but we definitely are not alone in this, and I think that's the way it should go.
So if we are to see these technologies deployed and used at scale regularly, a lot of things have to happen even now.
For sure.
In terms of synchronization and
For sure, because we can play, as Kristaps mentioned, here in our sandbox, but if we cannot compare the results with, for example, Germany, France, England, then it doesn't matter. We are playing only in our sandbox.
Lauris, any comments on that?
So speaking about the common methodology, I think that it's really important to have a common methodology. Otherwise, everyone will define the success differently. So a common methodology gives to the stakeholders like technology provider, network operator, municipality, regulator, the same language for testing. And it helps to turn demonstrations into evidence that can be trusted. Yes. Otherwise, if for example, they're trying to test some solution, so operators say, My network was available, so everything was fine. So technology provider says my drone was okay, it was flying, and payload data was working, but at the end, nothing was working. So if we have a common methodology, clear KPIs, we can go through and check what was happening. And
So you can trace the errors and you can trace success cases as well.
yeah, of course, yeah, and yeah.
Excellent. So Ilona, moving to that again, the end client, which all of this effort, which is not easy and not fast, is only worth it if we can actually have that kind of fleet operating, either the medical services or police or other emergency areas. What do you think are the practical barriers? The municipality experts and employees understand that kind of language? Are they involved in sort of synchronizing and working together, avoiding silos, all the classical tech speak?
It's, of course, difficult to engage all and everyone, but as I told you, we already use drones, and we have all those blind zones where we need beyond sight of vision flights. One example, we have a lot of connectivity lines on top of our roofs. If we would try to get there by feet, it takes so much effort, whereas our construction office can just fly there up and test it from the side. Okay, we see this and this and this, we can make photographs and we can analyze what's on those roofs without going up there. But then it turns out that some of those connectivity places or areas which they want to inspect are behind the sight of vision, and you cannot access them. And there we need this technology again to make our services better. As soon as we will have tried and tested that it's a reliable solution, we will be soon using it in many other locations as well. It's not just for the police sake. I believe that in that strongly, because there is a lot of need for this beyond of sight.
So in a sense, if we get, as Kristaps corrected me right, if we get a certain amount of pilots right, the gift keeps on giving. Once we get through some tangles and issues, we can then deploy, and the benefits are substantial there for the work of municipality and emergency services. So it's worth trying, otherwise this becomes a little depressing and dark in terms of there's so many obstacles to overcome.
I think it's depressing and dark because we all hoped that they will deliver pizzas to us. And it turned out that you need a private pilot for every drone which you run in the city, and it turns out become very expensive. It's cheaper to put them on the bike and send around the city. So I think that has been part of a kind of hope in a lot of people who didn't know anything about drones like me. I was, now they will deliver packages. And no, it won't be feasible in the nearest future because every drone requires a pilot according to EU regulation. And we see that it's possible somewhere outside of cities where you can already run them around and allow them to speak with each other and do these shipments and so on, but not in the city because, as Viesturs already mentioned, we want to be perfect and avoid any accidents with human lives and their health and safety, because even if it's a 3-kilo drone, when he starts falling from 25 meters, you get quite significant hit.
4 minutes, 5 minutes, 4 questions. Kristaps, you mentioned there are about 228 good landing sites, 368 okay, kind of gray area, and 69 which are no-go zones. So what does it mean to have a drone-ready city? Do we have to have decrease the amount of where we can't go, increase the ones where we have to go? So this is not a lot if you can, there are only 228 areas where we can park and safe and launch as well.
I would say 228 for that northern part is adequate, but you see just the difference between, I think the gray zone is the kind of preferred not to, or the 360 something zones I mentioned, because those are places that initially the software shows you should not go there, but maybe actually looking in real life or having negotiations, you actually can use it. So the number of areas where you could
be bigger.
Could be bigger.
All right.
But to say about a drone-ready city, I think there are three major groups you could see. Governance that I already mentioned before. You have infrastructure, both physical and digital. A lot of what my colleagues have been talking here, but also even the landing sites or these different elements that come together to provide the service. And the third one would be social acceptance in all of its forms of trust of citizens. Actually, a drone that's flying over you is a good drone for like good reasons, or even just being transparent of say a city is using drones for a specific use case, to actually communicate it ahead of time and be proactive about it. So I guess drone-ready city would be one that you just don't fight for the amount of drones in the air, but rather that actually it integrates into the city's whole ecosystem.
Oh, that's excellent, but this, I think, is going to take quite a bit of time for us to get there. Okay, last two questions before we finalize. And again, if do I see any hands, questions regarding from the audience? I think that, oh,
Yes.
that would be fantastic. Please introduce yourself and a question.
Thank you for all the presentation. Thank you for talking.
Do we have a microphone for the panelists as well? Or you don't accept microphone. Excellent. I consent. You can go without a microphone as well.
Okay, thank you. So thank you for talking about the citizens, because I have lots of questions, but did you ask the citizens what they think about this, and does they agree to that? Because in my country, France, sorry for that, we are 68 million, and for sure right now, it's a no-go. So how are you engaging the citizens into it, and is there any democratic process for that?
I have a whole different presentation about how we actually did the survey, and
But you did. It's a good thing. It's a short answer.
Yeah,
So we did.
we did, and the finding was when we compared all of our Stockholm, Helsinki, Hamburg, Riga, Tartu, Dansk, we saw that Riga and Riga's citizens are actually the most acceptive for different kind of drone solutions compared to other cities. The overall survey was about 6,000 people, overall whole project. So there are zones and areas where there's risks and where people are more apprehensive, say security, surveillance, and their privacy was probably the main concern. But yeah, we did, and we have that integrated into our survey systems.
One more question out of those 10 you have there, and then we finalize with the last question to the panelists.
I have a last one.
One more for France.
Well, for Europe, actually.
Even better.
Because we were discussing earlier that we need to make things as Europeans, but I'm hearing that Latvia is trying to have the leadership over the neighbors. How can we not talk about competitions, but cooperation, and what having Helsinki equipped by Latvia instead of trying to compete?
Well, it's impossible because we have Estonians next to us, so it's always competition. Jokes aside, who wants to take the question?
But I would love to answer. First of all, we have a partner in Italy who immediately tests also the similarity in this project. We also are engaged in many other projects organized both by Estonians and Lithuanians. We have been talking about this sharing every 6 months, trying to meet and discuss what we learn, what they learn, because there is so much what to discover in the drones area that there is no kind of, we do this one thing and they're very interested in finding out about us, whereas we are interested because I know that we were in Tartu, they were doing different kind of tests and feasibility studies, and they openly shared. We also had someone from Netherlands connecting and showing about their examples. So actually it's not wise, we will put a lot of resources to be the ones leading, but it doesn't matter that we are gonna kind of do not cooperate, because the drones ecosystem is rather small, and I'm talking to every producer.
Especially in a city airspace.
Yeah, especially in city airspace.
So it's just a matter of how to get Latvians going, put an Estonian in a room, and we start working twice as hard as possible. The last question for all the panelists before we go ahead. So if you would choose one thing, again, let's make sure that we don't have an inflation here. One thing that needs to happen between the network, the reliability, and the signal, and the drones technology itself, and the system, and the public sector side, that this would be a practical tool into the next 4 to 5 years. Who wants to start? Who's ready? Oh,
So
fantastic, we have Lauris.
So I think that the next step, what we need is to move from the demonstrations to the real life governed pilots. So we know that separate technologies, they are working quite good, yes, but if we put together a lot of things, a lot of blocks, we have a new, very powerful solutions. And the goal is not to prove that only separate technology works. We need to prove that it helps really to public safety services. Yeah.
Gins, Elon and Kristup.
Yes, adding on that, what Laura said, I think common framework is essential so that everybody knows his role and what he needs to deliver.
Learn the alphabet and learn the language of the drones. Elon and Kristups.
10,000 hours.
Oh wow, that's
I would say transparency to our citizens.
that's a short summary, isn't it?
Yeah.
I was expecting more, and thanks for finalizing. Okay, round of applause to Gins Jakvels from MLMT, Lauras Libanovskis from ECHO, Kristaps Steros, Riga City Council, and Elon Platonov from Deutsche Agency. Thank you so much. I think we're still on time. Any questions to the panelists after the show with the drinks at the back? Thank you so much. You have a great day.
Yeah, a big hand to all the speakers and to Vesturs. Vesturs, thank you very much. Thank you. Thank you. Yep, good. Take care. So we turn the page. We turn the page to infrastructure resilience. What happens when ground-based infrastructure fails? Maybe it's disrupted. Maybe it isn't even destroyed, it's disrupted. And in fact, just as an aside, I am working with the German Marshall Fund to launch a task force on just that, on how you, based on lessons learned in Ukraine, because it's happened in Ukraine, how do you prepare Europe for the unthinkable? To prepare civil protection, civil defense. Any case, that's just an aside. And what I want to do is invite Robert Ade, who is with Enterprise Estonia, industry liaison officer at the CERN nuclear accelerator. He's in the Estonian Space Office, over a decade working with R&D. Robert, please. A big hand to Robert, please. So, Robert, it's not just a theoretical thing. It happens, doesn't it? Disrupting infrastructure, and how can space fill that gap?
It does happen. Are there also slides? Yes, there are. Thank you very much. It's so nice to see so many of you here. So, I work in the Estonian Space Office in Enterprise Estonia, so effectively I work for the government. Enterprise Estonia is an agency answering to the Ministry of Economic Affairs and Communications of Estonia. And in the Space Office, what we primarily do is we carry out the Estonian space policy. How do we switch the slides?
Oh, sorry. It's right behind you, sorry. Right there on the table.
So we carry out the Estonian space policy. We have a program for 2020 to 2027. We are preparing for the next one. Mostly we carry it out through our membership activities in the European Space Agency. I provide some statistics here, but one of the key parts here is that we have some dedicated areas which we are more interested in than others. We do everything, but some areas get priority. I would particularly want to highlight cybersecurity here, but also AI and robotics and other things. We have been a member state since 2015. We have invested into ESA-led projects something like 50 million euros, and you see that for the next 3 years we invest 10 million a year. So we are accelerating in the pace of our investment. This corresponds by and large also with the other activities of other member states in the European Space Agency. We have garnered quite a community of companies, over 100, that have worked with ESA at this point. And based on our statistics, every euro we have put into ESA contracts generates another 3 of additional economic activity. And I use an old slide here with a lot of logos, just to show that there's different areas we have worked in, and there are different companies there. Some of them have a very interesting story, and I would particularly again like to highlight the area of Earth observation, which is the second largest. Earth observation is slightly strange because you do not need a satellite to do space-related things. And then there's a company called Skeleton Technologies, which started from space, but now is doing something big. So how do you get from just an idea to space? There's a number of avenues available for you. There's 3 areas you can start from. One of them is ground to space, which is what everyone thinks about when you think about space. That's launches, that's rockets, that's satellites, everything that you send up into orbit. Then there's ground-related things, which is big antennas, big data centers, places where you crunch the numbers and send the information around. And then there's space to ground, mainly information. This is how you can do Earth observation. You do not need your own satellite, but you can find information somewhere to generate it into something that you can use for something else. If you do anything within AI or electronics or something that you can use in any stage of this architecture, where first you send something to space, do something, observe something, take the information and generate it into something useful, you have a place in space, and there are some easy entry points available for you. One of the particular ones is the ESA Business Incubator. In Estonia, we started one in 2017. It's been slightly strangely successful. There's been 39 companies that went through it. We have only lost 2. Only 2 have died. All the other ones are still alive. If you look at the statistics, the equity-free funding they've handed out is below 2 million, but the additional funding they've raised is almost 100 at this point. We have a BIC in Latvia. There's an ESA BIC in Latvia, opened in 2024. I have no reason to believe it will be any less successful than the Estonian one. So if you're an investor looking for startups to invest into, pay attention, take a look at the startups they're in. But from a public sector perspective, if you look at the labor taxes and the high-value employment positions generated, this is an absolute success. But to take a step back, so if you think about satellites, what does a satellite do? What kind of information can you get? A satellite is a relatively simple object. It can, in human terms, listen, it can talk, it can see. It can also do a little bit of maths, but only a little bit, because it's usually constrained by power demand. You know some of the services, some of them you use every day. If you use a Bolt, you're actually using GPS, because that's how the Bolt taxi finds you. Galileo is the European version of it. Intelligence, surveillance, reconnaissance. Technically, this involves weather monitoring, but also if you want to see what ships are doing on fisheries, you can do that. There's other patterns. If you want to see how traffic changes in an area, if you install a new road or close one, or just generally observe a trend, you can do this. You can employ a lot of AI and read a lot of information. There is a term here, why I'm going through this point by point, hyperspectral imaging. This is kind of a technical term. I'm not sure everyone knows what this is. So if you're looking at these pictures, you see a number of pixels. They are blue, red, and green. This is basically hyperspectral imaging, but typically in space it just means you have a lot more colors you're looking into. And RF mapping, which means radio frequency, so anything that has an antenna, a phone, something else. You can see from space where transmissions are being sent and sometimes also where they're accepted. And of course, communication links. The picture I put here is S-Cube-1, which was launched a number of years ago, 2013, I think, and it's already dead, but it's just as an illustration that it has other functions as well. It's a scientific satellite, but it does have these 3 characteristics that are basic for every satellite. It talks, it listens, it does some numbers, and transmits some information. Now, since you can do...
Robert, can you back up to the previous slide again?
Yes.
The thing about dark vessel detection, does that have anything to do with killer satellites or something like that? Or
I'll get there in a second.
you will. Okay.
Yeah. So,
Teaser.
in fact, this is on this slide. Thank you for pointing it out. So space is inherently dual use because you can observe something quite basic. You get information. You can use this information for various things. But often the satellite information itself isn't useful on its own. You want to combine it with something else to calculate what's actually interesting. So one of the examples here is the AIS system. If you've ever gone to the page of marinetraffic.com or .org, I don't remember which one, you see ship positions, transponders from ships. Technically, on a ship, you can turn these off. and then you just disappear from radar. I mean, okay, you don't actually disappear from primary radar, but you disappear from the map.
I see. Yeah.
And
Actual ships. These are ships.
actual ships,
got it.
dark vessels.
Yeah.
You become a dark vessel. But if you have a synthetic aperture radar reading of the area and you see that there's a ship but there's no transponder code for it, then you can just go back in time and see when it last transmitted its location and name. And then you can calculate what it is, and then you can start figuring out what it's doing there. Is it doing illegal fishing? Is it trying to smuggle something? Is it one of the shadow fleet taking oil or trying to bypass insurance regulations?
There's lots of those.
Yes. There's other versions of this as well. I brought the example here of the ICEYE system because this is a characteristic case. They have a large constellation of synthetic aperture radar satellites. These are commonly used to monitor ice flow, also to see how flooding evolves in a situation. But the Ukrainians have also used it for detecting where targets is. So synthetic aperture radar can see through clouds. And in some areas, this particular image has a resolution of 25 by 25 centimeters and 2 coordinate axes, but the third one you can actually measure extremely finely because you can do interferometry and then you can get topology changes of something like 1 or 2 millimeters. So you can see a lot of things in space. You can, of course, also take a look at search and rescue operations. If you look at where someone's phone is in the forest and they're lost and they don't know where to go, you can detect that from space, but you can also detect other guys who maybe are not lost but are still in the forest and are trying to stay there so that no one finds them. And hyperspectral imaging we basically talked about, but you can see through camouflage and sometimes you can detect certain chemicals. Since space is inherently dual use, it means that sometimes it's targeted. Space itself is targeted. You try to affect a satellite in a military conflict to create chaos or avoid some information from getting where it should get to. There's a number of ways to do this. If you look at positioning, GPS, then currently here it's jammed. I took a flight into Riga yesterday from Paris, and as long as I was across Germany or France, I could track my GPS position on the plane. And then when I entered the airspace above the Baltic Sea, it disappeared. I couldn't get a lock anymore. There's a more serious case in Estonia because there's the Finnair flights that went into Tartu in southeast Estonia. One of the landing procedures required that the plane has a lock on its GPS location. And since that went away due to jamming, then they had to turn back to Helsinki. This happened a number of times. Now they've changed the technical setup, they've changed the procedure, but it's still something that affects the planes every day. You can also dazzle cameras on space assets. You basically shine a laser towards the satellite. It will usually not destroy the satellite or the sensor, but it will mess up the readings. So if there's a fire occurring somewhere in the forest, then you lose temporarily the ability to monitor what's exactly happening. And telecommunication is obvious because you just lose everything because someone else is shouting on the same wavelength and you just don't hear anything. The noise is too much to determine what the signal was. You get secondary effects then if space is disrupted. There's an example I brought here from Ukraine. So a few hours before Russia started their invasion of Ukraine, the KA-SAT SATCOM system owned and operated by Viasat went offline in most of Europe. They lost something like 30,000 modems that enable you to communicate with the satellite. Turns out the satellite itself was fine. But the problem was that one of the ground stations in Italy was the subject of a cyber attack. And the ground station was hacked and was instructed to push malware onto the modems. A malicious update that basically bricked all the modems. And the attack is largely attributed to Russian intelligence, although I haven't seen any article confirming that for sure, but it would make sense given the timing. But if it was an intentional cyber attack, then it still affected a lot of Europe. Something like 6,000 wind turbines lost their backup remote monitoring capability. That's a power generation volume of 11 gigawatts. If you don't know what that means, that's approximately 11 or 12 times what Latvia consumes on average. You can, of course, imagine other scenarios where some data links are just hijacked or jammed or spoofed, and then people go to the wrong places, people have difficulty finding out where they are. You lose ability to monitor some dynamic situations. Someone can use a ship to bypass border controls or do some smuggling because you can't see it from space anymore. So the point of this slide is to say that space itself is targeted a lot as well. You cannot rely just on space most of the time because it can also be affected. But as a backup and alternative, it has its role. It's largely limited to the things you can do from space, the information you can generate from space. Either you transmit information or you observe something and send the information back. The example here is a ship, Eagle S. It broke a powered cable. It broke also 3 optical cables, and then it was escorted away by the Finnish military. Even if this was accidental, then the case is still that fiber optic cables get damaged a lot. The other areas that can get damaged are navigation and timing infrastructure. You can determine your own location based off of telephone masts. Cameras that you put on borders, these can be damaged sometimes. And of course 5G, 4G data networks.
Robert, just a few more.
I have 2
seconds.
slides. I'll finish in a second.
Thank you.
But there are other areas. So there's definitely hybrid activity that causes these things. There's also natural disasters. I brought 3 examples here. One is a hurricane in the US. So a Hurricane Ian hit Florida. Entire counties lost a lot of their communication and power infrastructure. Companies came together, created satellite-based data hubs so that data connectivity was restored. Volcanic eruption severed the only data cable connecting the island of Tonga to Fiji, and by that the rest of the world. Now they are reportedly considering Starlink as one of their go-forward connections to the world. And then an earthquake destroyed a large part of Turkey and Syria, where not only was data communication used, but also, since it wasn't clear which roads can be used, they used synthetic aperture radar observations just to see how to guide logistics and help where they needed to go. So, final notes. You can use space as an alternative, but usually you can't rely just on space alone, except in certain cases like you're in the North Pole or somewhere where you have tundra or basically ice-based conditions, because there you just can't have a good alternative. It can primarily help with communication and information. If you're a company, again, I'd like to reiterate, look into what ESA does. If you can go to an ESA-related project, check out ESABIC. It's an easy way of getting some equity-free funding. If you're an investor, check out the startups in the ESABICs. It seems to be working for us so far. It probably is working for Latvia. And final thing, advertisement. Come and meet the Estonian space community in Tallinn at the end of October. Thank you.
Thank you, Robert. Thank you very much. It's great to hear. Dozens of startups, lots of projects going on. That's really great to hear. Thank you very much. Let's stay in space. How about that? Let's talk about thermal intelligence, how that could reveal what Europe is missing. Let's hear that from Max Agulda, who is CEO of Constellar, building and operating thermal Earth observation satellites. Max, please. Big hand to Max.
Hey, Chris.
Welcome.
Nice seeing you.
Off to you.
Okay, cool. here, this thing I need. Okay, let's start with a little story. Okay, this is Ras Laffan. So it's one of the largest LNG terminals in the world. 25% of global trade is going through here. And you can see it has gas-to-liquid facilities, there's a refinery there, and there's also the LNG production from Qatar Gas. Now what we do, we look at this in terms of activity. So this is a false color image. Blue represents low activity, low temperature. Red represents high activity or warmer temperature. And you can actually see if this is a night or daytime image. Here, the sea is warmer than the land, so you can infer that this is a nighttime image. And you see several things, right? You see flaring, you see a lot of activity in this Pearl GTL, and you also see a lot of activity in Qatar Gas. Now, on the 2nd of March, this thing was hit by an Iranian drone. On the 3rd of March this year, Qatar Gas announced that they are shutting down all production. And then prices spiked. This image has been taken on the 6th, so 3 days later. And you can see production is still on. Okay? It was then hit again on the 18th. And again, we took an image. We took it 2 days later on the 20th. And you can see that only now activity is actually reduced. So you can see it on the left-hand side over here. The laser point is a bit small. Activity is reduced. I'll go back, one here, and come back. And you can now also see increased flaring, which is usually a sign that things are changing. This is one of many stories where Earth observation data is used to validate or to show that there might have been misinformation. So what we are doing, I'm Max, you've already introduced me. We are a satellite operator, and we operate the most performant thermal monitoring fleet on the globe. So we have satellites in space, and now we say, oh, most performant, there must be many satellites. There's actually 2 at the moment, so the smallest possible constellation, but we're ramping up, and it already is enough to monitor the entire globe, any place in the globe, in less than 24 hours. So where are we when it comes to categorizing Earth observation? Usually that is what you see. What you see is images as if you would have a mobile phone from space, and that is to categorize objects, right? That is one of the primary, let's say, modalities in space. So you can see if it's a LNG terminal, or if it's a helipad, it's a car, a tree, an agriculture field. And what we also use a lot, and only recently over the last 10 years became really popular, especially in defense, is SAR, synthetic aperture radar. So basically sending radio waves down on the Earth, and then you look at the reflected signal. So it's kind of an edge detection mechanism, if you like, and you can see very fine details. Robert just spoke about somewhere in the millimeters when it comes to height, and in the centimeters or tens of centimeters when it comes to X and Y axis. So you can now look very carefully at the geometry of objects. And what we are in fact adding is the 3rd layer. And the 3rd layer is activity, behavior. So how are things behaving? Is this terminal on? Is it off? Is the engine of a ship on? Is it off? But also has the farmer watered the field or not? So let's see what the difference is. On the left-hand side, you see an optical image of Pevek. Pevek is a marine base in north of Russia. And you see it at night, and it's in the Arctic, so you see it's very gray. You can't really see anything, right? It's pretty dark. The middle one is a Sentinel-1 image. That's a SAR image. It's public data. And you see all these little lights popping up, right? There's all little vessels. That's the edge detection I told you about. And if we co-collect at the same time, this is what we see. Within minutes, we see a lot of traces. Again, false color. Blue means cool. Red means warm. And we see all these traces. And these traces come from ships moving through the waters. So as a ship, now I'm sorry to give you a bit of physics lecture here. I'm a physicist, can't help. But if a ship moves through water, what it basically does is it mixing different layers of water with different temperatures. So it creates a thermal trace. And we can follow that trace up to about 90 minutes. Let's zoom into this part and look what we can see. First of all, we can see direction. So there's a lower part which is slightly warmer than the upper part. Since in the Arctic, the upper level is actually warmer than the lower level. And we can therefore see that the lower part has about 13 degrees temperature, minus 13, and the upper one minus 15. And we see two ships moving through there. And we already learned from Robert that these ships can have AIS, the automated identification signal. So it's like, hey, this is who I am, and this is where I'm going. The first one is an icebreaker, the Sibir, which has AIS on, and the second one doesn't have AIS on. We can see, it's again a nighttime image, that there's a ship, and now we can task a high-resolution bird, for example, one from ICEYE, to see and identify what the ship is doing, and we can tell it, hey, this is where it's been, and this is where it's going. Let's look at a different site. This is a place in Ukraine. We're very active in Ukraine. In this case, it's a nuclear power plant. And again, false color image. Cool. And what you can see now is quite interesting. You can see the activity level of every single reactor. So again, identifying that's a power plant, you can use visual imagery. Seeing exactly how high the towers are, you can use SAR. But we give you the information of if it's on or off. And it's very striking, and everybody can see that. On the upper right image, you see this is how it looks when it's on. And on the lower right, this is how it looks when it's off. Because we look at this cooling cycle of the cooling system of this power plant. And we can even look at the difference in temperature from the ingoing water to the outflowing water and determine how much energy is produced. Now you can transfer this from power plants to other industries, because other industries also use energy. Imagine looking at an airplane hangar, or you're looking at a drone manufacturing site, or a refinery, or something else. In case, what we've done here is the Hongshun Bay, and this is in China, sits in China. And here we have actually looked at two very distinct sites which have nuclear power plants, and we can look at a thermal wake, or a thermal plume, so the amount of temperature increase in the water to determine how much energy is produced. And this is what we can do today. So the case I want to make is that in order to be able to have a good common operating picture, to know what's going on, we need to use several modalities. There's never one modality which is enough. And also this one obviously is not the silver bullet, right? But there's a case to be made that especially for things which are announced before we can see them. So someone is turning on the engine before this person heads out. A ship is turning off the AIS and maybe going off course before we see the result. Someone is shutting down a certain facility, an LNG terminal or a power plant or something else before something is happening in the markets. All of these things have a energy trace, and if we follow this energy trace and take the temperature fingerprint, we are in a position to tell what's happening, and that's exactly our job. And it's getting better. This is the current capability. It's actually an image of Toulouse, and just to maybe go full circle, the company has started in agriculture, then went to urban monitoring, even though the technology was originally developed for defense. And now we're back in defense. But we still do all the other things too, right? And most of our customer base actually is in agriculture, because they also need early warning of crop stress, early warning of lack of water, pesticide lack, and so on and so forth. So on the left-hand side, you see the current capability, what we have today. This is the city of Toulouse, and you can already see on the block level where there are urban heat islands. And just to give you an idea why this is important, by 2031, the estimate is that urban heat will lead to a loss of economic productivity of around about $1 trillion per year by 2031. That's quite a bit. On the right-hand side, you see where we will be in 2 years from now, right, with the next generation of satellites. But then it's going to be 12 satellites, not 2 anymore. And you can see that we're going down to the building level. And the next image I would love to show, but I can't show. By 2030, we'll look at a very single vehicle level. We'll not be able to tell if you're smoking a Gauloise or a Lucky Strike, but we'll be relatively close. And with this, I would love to get a couple of questions. So, Chris, I'm handing over to you.
Guido, Max, I'm actually out of time, unless there's one really quick question to ask for Max. Otherwise, you can talk to him during the networking break, which is coming up very soon. A big hand, too. Oh, yeah, okay, very quickly. Run a mic over here quickly, please. And if you give your name and title and serial number, that would be helpful too. So, one sec. Great. You can even stand up if you want.
Yeah,
Yep.
all this. So,
What's your name and title?
all this, Carlos Karlovskis, DevOps architect, IT lead, expert, whatever.
Good.
The question goes
Like
to your 2 satellites. Is this state of the art? How many that capable are there? Where are you positioned?
Yes. So it is state of the art. It's deep leading edge at the moment. We are still overtaken by similar exquisite assets from US military and 1 French satellite. There's relatively little information about Chinese and Russian satellites, so I assume they have these capabilities too. When we speak to our colleagues from the MODs, they tell us that by 2030 we've overtaken their capabilities. To give you an impression, the current capability is 1,000 times higher resolved in resolution than the best asset the European Space Agency has.
And can I just access it openly, or?
You would have to pay, right? So it's not free data. We do have a couple of free data sets, so if you're interested, very happy to reach out. We can check afterwards, and then we can see how we can make this useful for you. But there are definitely some free data sets to play around with.
Thank you.
That's great. Thank you for your
Welcome.
question. Yeah, and a big hand too. Max, thank you very much. Vielen Dank.
Hey, thanks, Chris.
Yeah.
Have a good
great.
one.
Fantastic. Great presentation. Now, what about energy? What about the energy, defense energy architecture of Europe? We want to talk about that with Niklas Lehnelt, co-founder of Pulse Train Energy Storage. Yeah, Niklas, please. Big hand to Niklas.
Hello, nice to see you.
Welcome, welcome. Nice to see you. We're talking about batteries that double as mobile microgrids. You have explaining to do.
Absolutely. And if we have a look at today's battlefields, then there is one thing that hasn't changed so far. They are extremely energy intense. They are demanding a lot of energy. And most of this was today and also in the past supplied by petrol and diesel. And that is the thing that significantly has changed. Nowadays, we are moving more and more into battery-based energy supplies, even in the battlefield. But as the battlefield, per definition, is likely off-grid, we need to make sure that this energy can be supplied. And that needs, in the best case, a very common and very standardized architecture to make it possible to use any supply that is available to then transfer it to our frontline and battlefields. And that is missing, and that is a thing that Europe still hasn't built. And that's why we from Pulse Train has set ourselves the mission that we want to build a resilient architecture platform that is able to be supplied over different missions and sectors without having any technology break in between. And to talk about this a bit more in detail, when we have a look into our NATO forces, then there is currently more than 2,000 different types of battery energy sources existing. They have different voltage levels, they have different formats, they have different chemistries, they have different plugs. Basically, all of them have been developed for a very specific use case, sometimes even a really niche use case, and there is not really a standard existing. Whoever is a bit close to the military might have in mind that there is a 6T battery existing. That is probably the battery architecture that is closest to somehow being standardized, but has a very limited use case application. And the result is that in the end, you have a very fragmented energy landscape over the battlefields, starting from land, going to the sea, up in the air, but there is not really any standard existing. And that was fine until the point where supply chains were more or less stable and where you could have been quite sure that whenever you're requesting a spare part or even a piece of technology is arriving at the spot whenever you need it. But as we reached a point of time where supply chains and the supply of parts and even battery cells is not as stable anymore, this fragmentation somehow comprises security. And whenever we can make sure that we are standardizing on this field and that we are providing a solution that is easier to implement and even adaptable to changing demands or even breaking supply chains, then this creates sustainable safety for our future. And that is why we are working on a standardized platform that can be deployed in land applications, in maritime systems, also in stationary storages for microgrids or even larger grids. And last but not least, also especially for unmanned ground and water vehicles. And the overall goal we want to achieve is that we have a very standardized electronics component, meaning basically a piece of hardware that is able to handle not only different cell formats, but also different stages of quality within those battery cells, and is also able to handle different chemistries of battery cells. Because whoever is a bit closer to the battery sector, there is a lot ongoing on the chemistry side, but also on the format side. And then if you even a bit deeper into this field, then you might know that the capability in Europe for producing battery cells is extremely limited. I'm tending to say it's not even really existing. And to make sure that we can work with what is available within Europe with a stable and reliable supply chain, it is very important to work on an interface that is able to handle really all those different types of cells, formats, and also chemistries. And that's what we are doing on the hardware side. So now you might have the question in your mind, that's fair enough if you have a standardized hardware component, but how would you fit them into different use cases? Because whenever we are talking about land platforms, so grids or unmanned vehicles, these are quite different applications and they have quite different demands, not only from voltage levels, but also like the volumetric space they are providing. That doesn't seem like a very easy answer. And you're definitely right, standardizing on the hardware side is not enough because in the end, the piece of hardware also needs to work within the product. And this individualization is basically done via our operating system. So in the end, you're defining by hardware what is the smallest possible entity you can use and then scale up according to the use case we are talking about. And with the software, the operating system that comes on top, that is the one that is defining the final use case. So depending on if we are talking about a UGV or a grid stabilization or like a portable energy supply, basically a power bank, what is defining the application from our side and within the platform is always the software. So you're way less reliant on changing the hardware and adapting the hardware, which takes time and is also cost inefficient in the end. It's always defined by the software from our side. So standardizing on the hardware side and individualizing on the software side, that is the key to have a platform that we are calling currently the Universal Defense Energy Architecture, or a bit shorter, UDEA. And what you get from this is not only a piece of deep tech technology, but also a standardized interface that can handle different formats and chemistries of battery cells. And as I was talking about the smallest possible unit, you might already assume that it is somehow built modular, and that is absolutely true. And with this modularity, you will get even a way higher resilience within the system compared to conventional systems. Because even if you're losing one or even several modules within an UGV, for example, the system is still up and running and wouldn't shut down after the first battle damage. What is also important, that the technology is adjustable to different voltage levels. If we're talking about UGVs, we are likely in the space between 400 and 800 volts. If we're talking about like portable battery storages, we are rather between 24 and 48 volts. And whenever we are talking about larger energy supplies, for example, for like base camps, then we are rather beyond the 1000 volt. And all of these voltage levels can basically be covered by the platform. Another thing that is important, especially if we're talking about unmanned systems, that the enemy can't get their hands on when such a vehicle was damaged and can't be moved anymore. And as a battery itself is already a type of explosive, at least depending on how you treat it, we can easily make sure that we light up the battery whenever it is needed and basically destroy and make sure that enemy forces are not able to grab the piece of technology and even use it against our own forces. Last but not least, hopefully, we are always talking about storing and never using such defense technologies, but in the end, we are always talking about stocking them. And whenever it's about stocking, that means most of the time that the technology, the equipment is sitting for quite a while in the depot before it gets deployed. And when I was in the military, there were still people only employed within the army to move depot vehicles from A to B to make sure that whenever they are needed, they are operating and wouldn't shut down because they were simply too long sitting in one place. And to have this serviceability, this is also quite easy for us to implement because in the end, it's more or less like a software optimization system where we can see what is the status of the corresponding energy system. So we can always tell when it's necessary to replace a module or if the system is in a state that can be deployed. So the faster integration in the end is made possible through reducing the interfaces and adapting and adjusting via software. And whenever we are talking about a platform and standardization, that also means that we have less effort on the logistics side because you simply have quite similar components in larger scales, and that means that the complexity of the overall logistics will also decrease. And again, coming back to the software, whenever you are able to adjust via the software, in the long term, this will always mean lower costs for such a system because whenever you change the hardware, there is hardware costs included. Whenever you change the software, in the end, that's engineering hours, but there is no hardware included, reducing the cost. And last but not least, the thing I just touched on with systems sitting in a depot, we can also make sure that the systems are up and running whenever they are needed, even coming from the depot. And breaking this down a bit more to a value proposition, starting again at the baseline, we are independent from battery chemistries and also formats, and with this are less dependent on the existing supply chains and can make sure that we leverage the resources we have over here available in Europe. The second point, whenever we talk about a platform, then it's also easier to scale it across different sectors and missions, and that's exactly what we want to accomplish. The third point, regarding resilience, whenever we talk about a military application, resilience is one of the major KPIs because the longer you can deploy a system, even under battle conditions, the better it is and the more superior you are probably against the other forces. So this resilience is realized while keeping the system up and running, even though you're losing several modules within an energy system, simply because we have the ability to bypass and replace those modules. And last but not least, the time is always changing, technology is moving fast, requirements are moving fast, and whenever you are able to adjust via software, that gives you time ahead of comparable technologies, because adjusting software is always easier compared to adjusting hardware. And as we are talking about standardized hardware and individualized software, we are basically ahead of time in terms of having a future-proof platform provided. And luckily, we are already working together with a large German industrial partner and are currently validating on the technology. We will be likely able to ship the first prototype systems at the end of the year and being ready for serial and large-scale application within the next 2 years. And now I want to invite everyone who is also in for the mission of creating a resilient, platform-based, and with this, comparably competitive technology to equip our European and NATO armed forces, wherever you're an operator, wherever you're a policymaker, a manufacturer, or an OEM, to jointly accomplish this mission.
Great. Thank you very much, Niklas. I have a quick question. I don't know if you heard earlier, but I'm working on this project for German Marshall Fund on preparing civil protection in the event of the unthinkable, a war on our doorstep inside the EU. And electric power is part of that. This could probably have a civilian application in terms of civil protection for hospitals, for schools, for things like that, right?
100%.
But you need that redundancy and the mobility at the same time, right?
100%. So the technology itself, it's coming from a civil use case and is perfectly dual use. So whatever moves or stays on the ground and needs to supply energy or consume energy is absolutely applicable for what we're doing.
I might be in touch on that. Any quick question here? Yes, please. Let's get a mic over here.
Hi. I'm Kristaps. I'm actually working from nearby building, Latvian mobile telco operator.
Oh, welcome.
But I have an engineering background in electronics, and I actually just was thinking about the solution. You said that your solution is modular and it can be applied to different battery chemistries. I was thinking, as you mentioned in the event of Unthinkable, let's say we can get a bunch of car batteries. But we can make them all together, maybe pull up the voltage as necessary, maybe to AC, 230 volts, right? But those batteries cannot be deeply discharged.
No.
Is there like a solution that you're thinking in that sense, or you're just considering lithium batteries, which can have high power and can be discharged?
Basically, for us, it doesn't really matter if we are talking about lithium batteries or basically under any other upcoming or even existing chemistries on the market. This is also a software question for us in the end. We can adjust the system-wide software to the corresponding chemistry. The challenge we actually have, if we are taking existing systems, that we would need to retrofit the electronics to it. That is one thing. So whenever you would have a passenger car that already has the technology from Pulse-Train inside, perfectly fine. You reprogram the software in the end, and you're good to go for whatever use case you're wishing for. But retrofitting would at least require to fit the electronics component to the cells and then deploy it on the software side.
Yeah, I guess you guys ought to talk after the networking
thank
break,
you
which
very
is coming
Absolutely.
right up. Again, thank you very much, Niklas. Vielen Dank.
Thank you.
Bis zum nächsten Mal. Ja, danke.
Bis zum
danke.
nächsten Mal.
Great. So before we take this break, we'd like to tap your brain. We'd like to ask you 3 questions, I believe. We're going to put up on the screen how you can connect. There you go. It's a Slido. And if you participate, you could win a useful greeting gift. So keep that in mind. So good to participate. There are 3 questions, 3 simple questions. First, use that QR code to connect. Use the QR code, or you can go slido.com and then hashtag 4018349. Either way. Are we all connected and ready? Yes. By the way, next, after the break, we're going to talk about cybersecurity and critical infrastructure. So very relevant, very related to what we just talked about. Okay, join the quiz. All right. Hello, everybody. Okay, first question. In which city and at which specific venue does Deep Tech Atelier 2026 take place? Where am I? Yeah. You guys had too much of the Cosmos liftoff last night? That might be a little difficult. Okay, great. Yeah, that's it. Okay. 100%. Nobody else on the moon? No. Okay, that was good. Question 2. What are the 2 main tech themes of Deep Tech Atelier 2026? What are the 2 main themes? Is it FinTech, CleanTech, MedTech, Defense Tech, or Agritech, EdTech, which are all very important, of course. Okay. MedTech, Defense Tech seems to be winning. And that's true, right? Yeah? Maybe? Okay. And question 3. Which edition, year number, is Deep Tech Atelier 2026? And which organization puts it together? Is it 8th, 6th, or 10th? That's important to know for the next time. Is it the 8th? I know which one it is. I won't tell you. Yeah. Congratulations, RK. Who's RK? RK. Yo, we have a winner here. Great. Excellent. I guess you get the gift, right? Anyhow, thanks. A big hand to everybody for participating. And take a quick break, and we'll see you back at 15:50, 10 before the next hour, talking about cybersecurity and critical infrastructure. See you then. Thank you very much. So, welcome back to the Deep Tech Atelier. Welcome, everyone. Welcome back after that great networking break. I had a great sandwich, a bao sandwich on the food truck. It was wonderful. I highly recommend. Those guys have been making these buns here in Latvia for more than 10 years. So they really know how to make it. The best gut bomb I've had for a long time. Anyhow, welcome back. We are talking, of course, about defense. In this case, we're talking about cybersecurity and critical infrastructure, cyber defense, data sovereignty, and regulation. And that comes a little bit later. Sorry about that. Yes. We are talking about, here we go. We are talking about sorry about that. Yes, that's what it is, cybersecurity, critical infrastructure. And keep in mind the tech tips, live translation, if you haven't done that yet. There is a, can we put that up on the screen? The thing you connect with? There is a QR code. There you go. That's for translation. It is AI, so it's not perfect. In fact, we're quite relieved it's not perfect in some ways. Because there are lots of translators in Brussels that are worried about losing their jobs. So anyway, it's a good translation, but it's not perfect. So keep that in mind. So the QR code, and also think about networking, because if you go on the BadgeMe app, you can connect with anybody here, and there's more than 2,200 people registered. 2,200? Wow. Connect with them, and you can meet in the B2B room over there. I don't know if you saw that, but that's right next to the demo sort of alley there. Check out the demos, too. They're fantastic. And or in the networking area. So, I do hashtag Deep Tech. There are lots of other hashtags, but if you hear something great during this session, please think of hashtag Deep Tech. Good. I think we got it. Let's go first to our speaker, Sébastien Garneau, who is founder of the Cyber Task Force and president of the Paris Cyber Summit. He advises governments, institutions. You make policy real for them. You connect them.
At least actionable.
Yes. You educate decision makers. You break walls between all those actors.
Trying.
Let's hear it, Sébastien.
Thank you so much.
Big hand to Sébastien.
And thank you for having me today. So I followed all the speakers before me, and that was so great. So maybe I will go very fast on my presentation because you've heard already lots of things. And please interrupt me anytime for questions, because I like interaction, and your questions are better than my presentation. So sovereignty. You might have heard that in the EU there is this debate about the definition of sovereignty, and maybe about digital sovereignty. The thing is that we know what it is, at least in France, since 6 centuries. So why are we losing time when time at AI speed, time is a strategic asset, and now we have the French president and Germany trying to define something that we know. So this is the people who wrote so many books on this, but I would like to suggest an actionable one. So sovereignty is a capacity fueled by power, action by government, and delivered by industry. This definition gives you the role of each one. What is a capacity? For individual, being Latvian or being French doesn't allow you to sign something. It's because you have your capacity as an individual that you can commit, engage, and contract with others. Same for states. If you don't have any capacity, then you cannot implement your sovereignty, which is a power. I'll give you an example. If you are a nuclear power, but the strategic core of your nuclear system is driven by a foreign country, you cannot action it whenever you want. So you don't have the full capacity. This is the idea. And we have this frame that explains you how we can define each roles for each companies, and it's rely on 4 pillars. The first one is constitutional asymmetry. Why? Because we don't have the same political organization within the EU.
Isn't that like the biggest problem? Is that
it's not the biggest, but
there are different ways that government operate within the EU27, and that's what's holding things up. Especially between, say, France and Germany. The French president can go to war like that. The German chancellor cannot, for instance.
So this is one of the problems, but the main problem is compared to our competitor or adversaries. Because when we talk about the USA or China, they are integrated top-down.
Top-down.
But we are bottom-up. And this is because national security in the EU belongs to member states. And why? Because every member state has its own priority. We are in Latvia. You are looking Russia in the eyes. They are your neighbors. I am French. I'm facing Russia in Africa. We are facing China in Indo-Pacific. So it cannot be the same policies, and it cannot be the same result. This is why we have this asymmetry, and this is why we need time to decide. But at the AI speed, we don't have this time. And it has been discussed earlier today. We have the market, we have regulation, I will talk about that, but we have this zero trust market. And when we talk about national security or defense, we are in this zone. So if the European Union is not a country, there is no sovereignty. It's not possible. There is no defense, and we know that there is no European army, which is real because we have the most spending into defense, but we don't have the strongest army. So this is something that we must address. The EU is using market as a tool to address this topic, and especially in cloud, in the cloud market. And regulation is then an incentive. So the zero trust market is when the risk meets the threat. The threat belongs to the states. They are defining what are the threats. For instance, the US are saying Russia is a storm, China is climate change, meaning that China is first ever. I'm sure that here you would say that Russia is also climate change. So this asymmetry of national security and defense vision means that we cannot cooperate at the EU level on every topic. It must be topic by topic. Then the zero trust market focuses on trust, which is real. But because you have zero trust by design, then you are building trust. Another example, if a Latvian company is teaming up with MBDA, because I've heard this company earlier, or Thales, or Airbus, or Leonardo, or whatever, we are in the trust circle, because we are Europeans. So our future is linked, and then we can go forward. But I give you an example of an alliance that has been a bit challenged. You all remember the Iraq war. And the French army went to Afghanistan, but didn't in Iraq. The US cut the ammunition of the French army for 2 years. This is sovereignty.
I didn't know that.
During 2 years, no ammunition from the US, which is a problem when you have an army. When situations are different, regulation should be different. So I'm advocating for a regulation for the market, but I would like a specific zero trust market regulation at the EU, where we can combine the money, the cloud, the compute, and the energy. These are the 4 pillars that we need to have AI supremacy. Because this is what it is about. When you're listening to China, when you're listening to the US, they want to be the first, the most powerful power in the world. It is not the case for the EU yet. So in pink, you have the perimeter of the EU, and outside, this is member states. How can we make it work all between us? By a global industrial AI policy. And we don't. The AI Act wasn't a policy, it was a regulation. We need a strategy.
Yeah,
so here our constraint as an alliance, a specific alliance, but still we still have 27 governments. National security belongs to member states. Innovation policy has no power strategy. If you are not working to have power, then you're not free. And freedom is something that you know here. You know what is freedom near Russia. Data residency is no longer relevant. It's more about data resiliency, but in my country, and I need you guys to explain to my politicians that it's not a good idea to say that sovereignty is nationality. And it's not a good idea that we need to have the data on our ground. This is the lesson learned from Ukraine, but this is also the lesson learned from Iran. Data centers can be targeted. If all your data are on your territory, then you're cooked. So how we can spread the data into trusted member states? This is a challenge for France because we have this nuclear topic, and this is why we are always saying, because this is the joke about us, oh yeah, you're French. And we say thank you. But then it's because we don't have the same problem than Greece. We are not facing the same threat. What is Europe AI power? It won't come from a definition from France and Germany. And I feel it is a problem that France and Germany want to define what is sovereignty without you guys. Because either we are a team or not, but we cannot do on our own and then say, oh, by the way, this is how it goes. I think it's not the mindset. So if we need a strategy, then we need to define what are the needs. What is the power needs of the EU? If you know what are the needs, then you will deliver, you will work on that, and we will be the first power in the world. And what for? To stay free, because at the end of the day, this is how we are working. This is why we are working for, having our wealth, growth, prosperity. But this means that we need to be independent. This is the mindset, and then because we know what we need, and you will know what you do, we can put all the money. We should stop spreading the money because it's equality. So I give you a bit there, a bit there. No, it doesn't work that way. And this is why we have so many, money spent into defense, but we still not have the best defense in the world. That exposed us. So we discussed about NATO, we discussed about the European Defense Agency, we discussed about the bilateral defense agreement. It takes time, it takes money, it takes resources, but it didn't deliver. We need to deliver, and I'm happy to answer any question to make this thing actionable for the coming years, because our politicians are very short-termist. They are thinking about the 2, 3, 4 next year, at least in my country. But China, Russia, and others, even the United States, are building their prosperity for the century. So how can we team up to make things happen? Because again, the threat is there. We are facing the same threats, and we are answering differently. It's not good, because if we are not teaming up, then we are weak. But Europe is not weak. We are nice, but we are not weak. We're strong. We have lots of assets, but we need to engage way more together on an actionable approach. Thank you very much.
Thank you, Sébastien. Thank you. Is there one quick question? Because I'm trying to stay to time. Any questions? All
The
right,
first
please.
one is-
Yes,
oh,
get a mic over here.
Hello first. You kind of answered it.
Name and title. What's your name and title?
Yes, my name is Arnold.
Hello.
So I'm building out a cloud. Pretty much, we have a.
Who are you with, Arnold? Which
yeah,
company,
so
organization?
I'm from Lithuania. I
Yeah.
have a venture arm as well myself,
Okay.
and I've been incubating, accelerating some companies, etc. So
good.
And I have a team that's coming from a Lithuanian actually team that's coming from US. Spent over like 20 years building cloud computing and etc. So the question is, how is there any kind of capital? The cloud itself is capital intensive, right? To build out it in the Baltic states or in general in Europe. Is there gonna be kind of incentives for that? You mentioned like a very targeted ones, but I guess like the cloud or computing centers in general in Baltic states, it wouldn't be a priority, right? It's could be targeted. So it's a mixture of equations, but first the incentives, and it doesn't make it. Does it actually make sense to build out here in Baltic states?
Of course it does. Thank you for the question. We are linked. You guys need to extract your data. If Russia are going into your territories, you need to extract your data somewhere. Let's make it in France. We have nuclear power, so it's great. But this is true for us also. I mean, if we have anything, we were talking earlier that Russia is far, but it's close. It's 2 minutes for a missile to get into Paris. So it's the same for our data centers. So we need to have other suppliers that we can use to replicate the data far from us. So of course it makes sense, but I think that your project, your company needs to be fueled to grow fast, but we cannot finance one cloud by member states. Otherwise, we are cooked. I'm not sure that the French are the best. I know that the Germans are great. There is other. We should probably like target 6, 7, and make the money on it. That's my opinion.
Add?
Yeah,
so
quickly.
Additionally, for sure, we would be distributed like all over Europe, and the key goal is as we pretty much the presentation about severity and distribution, but Europe first, right?
We are first.
Europe.
Europe. Sorry. Yeah. Exactly. Well, but again, it's absolutely not the mindset in my country. In my country, the cloud provider, the French cloud provider, are pushing sovereignty as a nationality topic to have the money. So this is why nationality is not the good criteria. But regarding your question, if you ask a French, he would say, "Oh, I want my national cloud." That's crazy. We cannot afford to have everything at the same place. So again, come to France. I have also my summit in 2 weeks. Come to France. We're going to discuss the transatlantic reset parameter with the US, with others. Come to show you, to try to find some French that will pay you for what you're doing. And we can help for that because we are connecting people. We trust that this is the only way. You know, there is AI, but I'm working on plan B, on BI, biological intelligence, which is our. I think that the people are faster than AI, at least if they know each other. This is why I'm very grateful for Riga and Latvian welcoming me today.
Great. Sébastien, thank you very much.
Thank you.
Sébastien. Come to the Paris Cyber Summit to talk further about that. Let us move on to this idea about how do you survive a lunar night with no power? Imagine that. Let's hear that from Sotirios Zompas, who is Tech Development Manager at the Lunar Outpost EU. Sotirios, please, a big hand to Sotirios. Yeah.
Thank you.
Great.
Thank you, Chris. Right. Hello, everyone. My name is Sotirios Zorbas, and I'm here from Lunar Outpost, and I'm going to talk to you about the technologies that will bring to the moon, how they can be used for Earth with a spin on autonomy. So to start off, a few words about Lunar Outpost. So as a company, our mission is to enable human permanence in space through advanced mobility and infrastructure layers. And you can already see our approach. So we are a hardware-first company, and this is an example of a hardware that we delivered to NASA last year, actually. But I'm going to dive into that a bit more later. So at Lunar Outpost, we are a global company. We have our headquarters in the US, specifically in Colorado. About 9 years ago, we were established. We have an office in Luxembourg, which is where I'm working from, and we also have a presence in Australia. All the different teams have their different needs. In the US, it's mostly on mobility and robotics. In the EU, it's thermal control and lunar night survival. And in the Australia office is focusing more on autonomous systems and extreme environment for robotics. So when we start thinking about how we enable human permanence, one of the images that comes to mind is the creation of a lunar base. Actually, this comes into agreement with the newest NASA plans that were unveiled a couple of months ago, where in 10 years they envision to have a permanent human base on the surface of the moon. And if we start looking a bit more about what elements are active in that base, we can think of prospecting and exploration, so meaning having small rover platforms that will scout the area and find key resources that could be utilized for the operation of the lunar base. We think of autonomy and multi-agent collaboration, where different systems speak to each other seamlessly to accelerate different activities. We talked about the development of the infrastructure itself, and also enable human permanence by utilizing the resources that we find on the moon. However, a lot of times when what we miss when we think about this image is how do we get to this vision? And this is what we're trying to enable at Lunar Outpost. One of the key elements to enable that is long-term operation. And part of that answer is to do that through robotic crewed air mobility. As you can see in this image, most of the operations is done through robotic platforms. So that's what we are enabling. We have regular lunar missions that are reaching the surface of the moon. This vision started last year with our first mission that went to the lunar South Pole. As you can see the platform there on the left-hand side. And we are the only company globally that has 5 contractual missions that are going to the moon until 2030. And as you can see, we have a lot of different customers, such as space agencies. We're talking about NASA, Australia, Luxembourg, Europe. We also have private customers from Nokia, which was our flagship customer in the first mission. I'm going to talk about that in a bit. And we also have some other customers that we couldn't even think of, such as Lego or Juventus. So our target is to satisfy different payloads, no matter where they come from. And we do that incrementally by utilizing the hardware to its extreme and allow it to feed on to the next platform. In that way, we're able to increase the autonomy from teleoperated rovers in our first missions to semi-autonomous to fully autonomous, where, for example, in the last mission that you can see Lunar Voyage 5. One of the rovers is going to be collaborated with an astronaut that will enable him to provide direct commands that will be translated into actions from the rover. Talking more about our missions, this is an actual image from our first mission last year, and you can see our MAP rover, our mobile autonomous prospecting platform at the back there inside its little garage, so that it can be kept nice and warm. And this is actually a very, very important step for the lunar economy, as this rover was the first commercial rover that made it to the south pole of the moon. So it's a great, very important first step. Here I'm describing a bit more about some of the payloads that were on board. Just a few to highlight here. We have 3 different payloads from MIT. On the top left, you can see at the top of the rover, we have a smaller rover that is called Astrant that took temperature information on the top of the rover. We have the MIT resource camera that looked at different resources that exist on the surface of the moon, and also the Human's Disk, where there were a lot of different voices from all across the Earth that made it to the moon. We also had some other payloads, such as the one from Juventus, that enabled them to be the first football club that reached the surface of the moon. And the core payload was what you can see at the top, those 2 structures. These are actually antennae for Nokia, so that they can test their 4G LTE network on the surface of the moon. So these are some of this is the vision that we are enabling through our robotic platform.
What's this crypto treasure chest?
Great question. So the idea there was that we were able to sell the cryptocurrency to different people, and then the code of that treasure chest was prescribed in a specific location in the rover, and that enables the first lunar treasure hunt to take place, which means that whoever wants to go there and find the rover and get that code will get access to all the cryptocurrency.
Oh, so that's for much later.
Yeah.
That's okay.
Yeah.
Interesting.
Exactly. If cryptocurrency is still a thing, which I hope it is.
Interesting.
Moving on to our vision here, so we're also building human-rated vehicles. So this is an actual vehicle that we have built, as I mentioned earlier, for NASA, where Lunar Outpost collaborated with big industrial prime, General Motors, MDA, Leidos, and Goodyear to deliver this vehicle for astronauts to survive on the surface of the moon. And you can see here some more pictures of different prototypes. We actually delivered 6 different prototypes to NASA in the course of a year. So it was a great, great effort from the US team there. And we built all different types of hardware and different mock-ups for different tests. So we had actual astronauts suited going into the vehicle and figuring out the different controls to see how much they can reach. We had it go into a dusty chamber to simulate the lunar environment. And of course, what we spent the most time on was actually outside on one of the big facilities that we have there in Colorado. So direct use case of this vehicle on Earth is actually through autonomous ground vehicles, or AGVs, as similarly to the surface of the moon, these vehicles are expected to operate in the harshest environments known to humankind. So this is something that we have as a philosophy when we build our lunar terrain vehicle. So in that note, what it can enable is self-sufficient power. As you can see there, the solar panels in different configurations. It can enable resilient communications. It can support mobility and logistics operation, and also terrain shaping and infrastructure. Now, I'm moving more towards another big problem on the surface of the moon, which is lunar night survival. So actually, the problem that most missions face right now is that they can only operate for up to 8 to 10 days on the surface of the moon. And the reason is that during the lunar day, there are 2 weeks of constant illumination that bring up the temperature at around 130 degrees, followed by 2 weeks of constant darkness where the temperature drops to minus 180, which is way beyond what most electronics can survive.
Talk about extreme weather.
Exactly. So what our answer to this problem is our Lux thermal system, which is infrastructure that enables heat and power as a service. So it's an autonomous infrastructure that can be laid down on the surface of the moon, and it can provide up to 100 watts of heat, 55 watts of power, and also maintain a small thermal garage above minus 20 degrees. And we have been building this infrastructure for the last 3 years, actually, and we aim for it to go to the moon before 2030. And this is how it works. First off, it is able to collect solar flux through a series of lenses and mirrors and concentrate it into our thermal energy storage. And this is an actual picture of our hardware that we're developing in Luxembourg into our thermal vacuum chamber. And then we are able to control that heat with some hardware that we're also developing in Luxembourg, such as multi-layer insulation. And then we are able to convert that heat to electricity and provide power to vehicles as well that reside into our small thermal garage that you can see there. And also, on top of that, we protect it through deployable multi-layer insulation elements from the harsh environment of the moon. And speaking of harsh environments, an example of one of the examples that this platform could be used for could be to survive extreme conditions on Earth, such as the Arctic or the desert, to support remote defense operations, for example. The last thing I wanted to touch upon was related to autonomy. As you can see in this picture, it would be nice to have independent robotic platforms. However, that creates a lot of extra work for the operators to be able to control each one individually. So you really need a way to sort of merge them together. And that's what we have done with our software suite. So we have 3 different elements of software that we are providing and we have developed. The first one is Stargate. So this is the main piece of our mission control, where the operator can monitor and command not only one robotic platform, but also a fleet of them. And this actually was something that was raised to TRL-9 last year through our first mission that went to the moon, and it actually had a 99.998% uptime, which is similar to human-rated missions. Our next platform is Spark. So this is an AI agent that is able to transform commands into verifiable and compliant actions from robotic platforms, and it enables that through voice, text, and GUI integration. And the last aspect is Starweave. So this is software layer that can be pushed into different robotic platforms so that they can be working together as one fleet or a swarm. And this is something that we have showcased with our in-orbit demonstration mission that went into the low Earth orbit environment actually last month. And this was Mars 1, or Mobile Autonomous Robotic Swarm. And essentially the point of this mission was to enable virtual mesh networking by having different satellites with the different layers that I talked about earlier. So specifically, Starweave enables to have this fleet control for 2 different heterogeneous platforms. Then you have Spark that within the platform is able to enable predictive health monitoring for the satellites. And also we have our mission control that is able to command control and communicate through the ground and those satellites. So just to wrap it up, of course, all these technologies are cool, but what is even more cool is the team behind them. And here is a picture that you can see from our team in Luxembourg, and we're actually a very multicultural team. We have 13 unique nationalities in almost 20 people team. So I'm very proud of that group. And with that, I will end my presentation, and I'll be happy to take a question or 2.
Sotirios Efcharisto, thank you very much. I'm so sorry we have to move on, but to stated time. But there will be a networking reception, so if you want to pitch any questions to Sotirios, you'll be around, right? Great. Thank you very much. Thank you. Let's move then quickly to this idea about what do you do with spent nuclear fuel, nuke junk? Well, we usually bury it, but there's another idea. And Mikhail Szczepanskis is coming with it to show you. Well, not any nuke junk, but I mean, you're going to talk about it, right? You're head of, big hand to Mikhails. You are, welcome. You are founder of CEO of Deep Space Energy, head of science group on emergency energy tech for space. You're at Riga Tech University. Spent nuclear fuel. Wow, that's a hot topic.
All right, yeah, so probably we will speak not only about nuclear fuel, we'll speak about the moon, we'll speak about the defense satellites, and about the nuclear energy as well. So actually, this long title, but I want to pay your attention on 3 words. It's nuclear, military, and lunar. So those 3 words we just probably from the first impression doesn't go well together. I will explain actually how they contribute each other. And probably today is not the first time in the history that those 3 words came together. There was an Apollo time, so you all know what Apollo is, right? Or was actually. So Apollo was a very interesting project, so program actually. John F. Kennedy once said, so we do that not because it's easy, but because it's hard. And this is what he meant, that nuclear technologies powered ability to survive lunar night, and that was all needed in the time of Cold War to build missiles. And because of that, we know about the moon, almost everything we know about the moon today. So that was just a very good example how those 3 words work together to benefit each other. And today, I want to walk you through first defense application and need in defense, then on the moon, which, thank you, Sotirios, already covered in the last presentation as well. And then I will explain you actually why we in Europe have very unique opportunity, unique assets, which is nuclear waste. Waste. No, it's not waste, but it's asset. I will explain. Yeah, so let's start with the defense. So there are, do you know actually there are giant geostationary satellites, and military geostationary satellites cost from $1 to $4 billion each. Yeah, this is just the image because I cannot show you the actual picture of the early missile warning satellite. It's maybe classified, maybe not, I don't know, but I don't want to interfere with that. Okay, so that's why I just show you some picture, some image, but it gives you impression how it works. So basically, there are giant satellites which look on Earth and they see the half of the Earth because they're on the geostationary orbit. And they can detect the moment missiles are launched. And this is the basis for early missile warning and actually the basis of the system which actually can intercept missiles and prevent them hitting the targets. There are another satellites called COMSATs, so they ensure strategic communication. They're also placed in the geostationary orbits. So again, so these satellites cost from $1 to $4 billion each, but they are extremely vulnerable. They depend on solar power. The all power budget they have is from sun, and batteries. It's what's in shadow. You just rely on the batteries. If battery go low, so you have a problem. And such satellites are extremely vulnerable because they are huge, actually giant, and their trajectories are very predictable. So we are not only in the universe. So if you place such $4 billion asset on the orbit, you rather want to protect it. But so there is one important thing: adversaries are smart, and actually we should not blind ourselves. adversary are smart, and the first thing they want to try to take down your asset, just to make you blind. And it's already happened. The first thing, it's proximity operations. So I just put here the couple of titles, how it's already happened in the past. So nowadays, those satellites are more, it's not like a passive satellite, it's more like a spacecraft. So they change their trajectories very, very rapidly and quickly. Actually, they spy to each other. They spy to each other a lot. And this is the way they try to interfere and try to compete on orbit. So this is the one thing how you can act against your adversary, just to make some proximity operations. Then another thing, and actually the easiest way, is to drain batteries. So if you catch the satellite in the eclipse and you drain batteries, then it just become useless. 4 billion asset useless. So that's also the threat. So it's relatively easy to interfere with the budget, with the power budget of such satellites. You can jam that. You can also just make them work. You can also cyber attack the different systems on board, which end up on disable asset. And the last, probably but not least, this should not happen. This science fiction yet, but actually in NATO there are a lot of talks and scenarios of space-to-space laser attack. Then attack goes to the solar arrays of the adversary satellite, and eventually it becomes blind. And if it's blind, it has no power. If it has no power, it's just a junk on orbit. Junk which cost $4 billion, right? So, but this is $4 billion. I repeat that many times. But actually, the most important thing: what is actually the cost of missing that missile launch? So, what is the cost of that asset not working at the very moment that it's supposed to work? Right. So that's actually, I even don't want to quantify that, honestly. Yeah, that's about the satellite. So what I want you remember, is that energy is the key. So energy of such satellites are the most vulnerable thing, and we are going to address that in a moment. But before doing that, I would quickly go to the moon. So there is energy crisis on the moon. I like this title. Actually, this is from the paper. And yeah, that came exactly in the moment that we got the energy crisis in the Middle East. But actually, yes, there is the energy crisis of the moon as well. As previous speaker explained, so the moon night survival, it's a huge topic. For those who follow the moon agenda, you probably heard about the NASA Artemis ignition event. They demonstrated this picture that says science fee. So basically, this is how NASA see surface of the moon and moon village or moon base in few years. So it's science fee until the moment then you understand that NASA already spent $93 billion to make it happen up to date. And it's not the end of the story, just the beginning. Just in comparison, Apollo program cost $300 billion. So this will go probably to trillion or something. So it will happen, just because there is a lot of money already put there. And the question is how to make it happen, and whether we will take part of that or not. So the first thing is lunar night survival. I don't want to repeat that, but just in the simple words, 1 kilogram of the mass you bring from Earth to moon costs $1 million. So rover, which is 100 kilogram, will cost $1 million to bring to the moon. And in order to survive lunar night with 100 kilogram of the rover, you roughly need approximately up to 100 kilogram of batteries. So it's just kind of nightmare. And this is the reason why alternative solutions, like the previous speaker told you, exist and will exist, but there are also another solutions for that as well. Another thing, okay, you are on the moon. What else? So we want to support life there. They want to not bring everything from Earth there. The first thing is oxygen and ice. Oh, not ice, but water, actually. And there are evidences that are already there in so-called permanently shadowed regions. So in order to go into the permanently shadowed regions, you cannot rely on sun because it's permanently shadowed. So you need something else but sun. Yeah. And the last but not least, actually, nuclear power will power the majority of activities on the moon, and this is actually also the title from the articles. Now NASA really want to put nuclear reactor on the moon, and they want to be first. And actually, they are very serious about that. By the way, it's kind of also referred to the Cold War competition when. Then they were so rushed to put the first human on moon. Now they very rushed to put first nuclear reactor on the moon. And the consequence of not being the first on the moon with a nuclear reactor is very huge for them. So yeah, they will do that. But when you look on the nuclear reactor on Earth, look around, you will find some either diesel generator or hydropower plant just next to it. Why? Because you need backup power for them. You do not have such luxury on the moon. So as a backup power, you need something, again, not depending on solar, but not hydropower because there is no rivers on the moon. So luckily, there was already a solution in the past. Back to Apollo. In Apollo time, they used so-called radioisotope thermoelectric generator. You see there the picture, very nice picture. Then astronaut Alan Beam just took radioactive material from the lander and put that in that small gray box on the bottom, which is actually generator. And that generator can create electricity no matter what from the nuclear stuff. The problem is today, but that day it was plutonium-238 used, and it was the byproduct of the nuclear weapon production. So today we don't have that anymore. So we still have nuclear weapons, but we don't have nuclear weapon production. And if somebody wants to produce nuclear weapon, I really don't. Actually, you don't want. So just look around, look in the recent activities in the Middle East. You don't want to produce nuclear weapon anymore. We have quite a lot of them already. So we need to look on alternatives. So because today we don't have this luxury, and the alternative is nuclear waste. So just waste is not waste. So when you speak to scientists, never say nuclear waste. Use fission products because it's not waste actually. It's asset which we have.
Or spent nuclear fuel.
Yeah, spent nuclear fuel. That's good.
Right.
Yes, fission products. So they actually because you cannot take those radioactive materials from Earth. They are not abandoned. We already created them. We created them. And now the question how to use that. And in Europe, we have a very unique position because there are two countries in Europe, France and UK, who not just put that waste somewhere and wait until it for 1,000 years, but they do reprocessing. So they first separate uranium and plutonium out of the all radioactive material there. And because uranium and plutonium is very active, and then they can store everything else cheaper.
Just a reminder, we have 2 minutes, right?
So then plutonium and uranium, actually plutonium-241 decay in americium-241, and we can extract that. And this is the new fuel. So basically in Europe we have new asset, which is nuclear waste, and we can derive americium-241 from there. In our company, very quickly, I just want to make some advertisement. We solve this problem. So just comparing with Apollo, we do radioisotope power generation based on americium-241, and americium comes from nuclear waste. That's the first difference and advantage. So we actually, with the help of Arano, which is a French company, we recycle nuclear waste. And the second, we have our unique conversion type converter, which is 5 times more efficient than back in Apollo days. And because of that, we really can power. We can power both satellites and also lunar rovers. Yeah. let me actually end my presentation with nice words once said by Alan Kay. The best way to predict the future is actually to invent it. And in Europe, we have unique assets, which is reprocessed nuclear waste. So I believe that we can invent the future, we can use that nuclear waste, let's say, for our safety, building sovereign geostationary assets for early missile warning and strategic communication, and for our prosperity to unlock moon economy. Yeah, thank you for your attention.
Thank you, Mihalis. Thank you very much. Thank you. And so don't go away. You stay up here, and you're going to do a fireside chat, actually. We're talking about from GPS to doctrine, what Europe can learn from America's space defense playbook. And I'd like to invite John Shattuck up. John Shattuck, welcome. He is the space and defense and space consultant, founder of Shattuck Advisory. Welcome, John. Welcome. Based in the Czech Republic.
Right, in Prague.
Right, and you are mentor to a lot of startups, so be good to talk to him after at the networking evening. Take it away, guys. Yeah. Yep.
Yeah, probably.
All right.
Yeah, hi, John.
Hello.
Yeah, well, you are your first time in Riga, right?
It's my first 24 hours in Riga, so yes. Yesterday
Well,
it was
actually,
raining.
You came in very, very weird time, so we just we have no cabinet. It's resigned recently. Before that, we got Ukrainian drones redirected by Russia, struck our infrastructure in east, and then we got our defense minister fired. Well, it's like very weird time. This is the reason why you came here.
Maybe. You never know.
I hope no. I hope no. Yeah, but please, John, introduce yourself and tell us what's your expertise in space and defense.
Sure. Sure. I'm a former U.S. Air Force officer. I'm a meteorologist, a climatologist by education. In that, I basically spent most of my time with satellite data. And so basically it was meteorological satellites, but all that evolved into other types of satellites as well too, because as a meteorologist, I quickly found out that you have to know everything, but every client's and customers' needs are out there and how that we could support them. So that's sort of how I got involved in satellites. So my master's degree is in meteorology, but it's applied radiative transfer for microwave imagery, so I'm very familiar with that area of the spectrum. And so, yeah, so that's essentially what's happened. I spent 40 years, 30 years active duty, another 10 years as civilian, doing the same job basically. And the last 20 I basically did helping with the requirements acquisition process within the Air Force, helping the warfighter basically understand what they needed, translate their needs into requirements that we've sent over to a program office, to a large contractor like Lockheed Martin or somebody like that, to develop capability for us and for the warfighter.
Yeah, thank you. So let's speak about satellites and satellite-based defense. Yeah, so you're in Latvia today, and please explain us actually how does it work? So why we need satellites and how information actually move from satellite to the real operational decisions and why it's important.
Sure. So long ago, before I was ever in the military, we first launched our weather satellites and so forth, and so over time things have gotten more and more important as far as satellite imagery, especially the EO side, but there's also the comm side of it as well, to basically translate or move information from one area to the world to another area of the world very quickly through satellites, through GPS. So back in the day when I used to fly, we used something called Omega Navigation. Now we have GPS, and GPS has taken over that. And Omega Navigation, if you've ever heard of it, if anybody's ever heard of it, is long gone. But that was something that we used to basically triangulate, to basically determine your position on the world at the time. So, but yeah, it's become more and more important. You know, I think everything we do today has some aspect of satellite related to it. So, you know, communication, EO, you name it.
Yeah, actually, now Europe investing quite a lot, especially Germany. So actually, Germany allocated quite substantial budget to build sovereign space-based intelligence. So we use typically those three letters. I probably need to introduce to everyone because we probably will use that quite a lot. So ISR, so it's intelligence, surveillance, and reconnaissance, right?
Correct.
So it's space-based ISR. It's Earth observation, it's synthetic aperture radars, also some constellations, so we have, like, let's assume we have that. So what then? Like, how we can use that just to really protect our. Okay, let's go to eastern flank. So we're in eastern flank. So how we are going to protect our eastern flank using those assets? So if you just bring us very sample example how it works.
Sure. I think with EO and SAR imagery, synthetic aperture radar imagery, you are basically able to look at what's going on right now. Well, after the data latency from the satellite flying overhead to get the downloaded data to a user in hand, somebody to analyze it and everything like that. And so you have that data, but that's only one piece of the puzzle. You have that data, you can see what's going on at a given airfield, rail yard, what have you, very quickly, but that doesn't have enough intelligence value to basically determine what the enemy is going to do with that, or the adversary is going to do with that. So you need the other satellite imagery, the SATCOMs, you need other types of imagery, you need different layers to do this. For instance, drones as well too, so you need persistence surveillance. In Afghanistan, we had drones over there, the big global hawks or the predators, and they monitor things. Things are a lot different now in Ukraine. But you also have the satellite capability, but satellite polar orbiting LEO satellites basically come overhead. One orbit is about 100 minutes, and so it's only over your area a little bit of time. So that doesn't give you the persistence unless you have a constellation of satellites out there. So that's sort of where you need to go with it. So you need not just the EO and the SAR satellites basically to protect you. You also need the other satellites as well too, the SATCOMs and so forth. But that's not the end of it. When you're having all the satellites, you also need to have somebody on the ground who basically have the ground systems to basically ingest the data. You actually have to have the analysts who understand what the data looks like so they can take a look at it. And that's a very unique skill set that basically to derive information out of there that's actionable by a commander, that you need to basically have somebody highly trained and qualified to do that. The commander doesn't want to look at that satellite imagery. He doesn't care. He wants to know, can I do this or can I not do that? And so it's the analyst's job to basically take all that information in there, give him an assessment of what's going on, and for the commander to make a decision based on that. But that's all part of the mission chain that you need, basically from the satellite to ground stations to basically the analyst. Somebody's basically going to basically task the satellite, who's going to basically look at the imagery, enhance it, and disseminate it to the warfighter who needs it. So let's say in EU right now, we don't have that capability as much as you do in the US. You do have the capability somewhat, but right now underneath NATO, I think it's 80% of all the ISR satellites are in open source. Intel shows that it's from the US. So it means the remaining 20% are here in Europe somewhere. And so for ISR sovereignty, you're not going to be able to do that without having a much greater, more assets, but not necessarily more satellites. That's not necessarily.
So basically what you say that there is little sense just to put a lot of sensors there without actually building entire decision-making chain to the operation decisions, right?
Right. So and a lot of people
we have gap right there.
Pardon me?
We have gap there.
Yeah, I think so. And so we do have a lot of countries trying to put up satellites. For instance, Czech Republic is talking about putting up a satellite by 2030. Okay, that's one satellite that's going to fly over Czech Republic for about 1 minute. And so what happens the other 100 minutes of data, what's going to happen to that? So it's kind of a waste of money from my perspective. I mean, it's great that Czech Republic has this, if other countries are doing it and putting up their own satellite, but there's no EU constellation, other like Copernicus or something like that, but for the EO sensors that are very high resolution. You do have ICEYE here in EU, and they do SAR imagery, and so that's very good. I think that might be the only one, maybe one or two others I'm not familiar with, but I think that's where you do have some of that. But they are also have ICEYE US, and so if they have a large contract with the U.S. military, like I believe they do, and what we've seen with Planet, which is a U.S. company, and Planet restricting access to the Iranian theater of operations, that becomes an issue if ICEYE, largest client, is the United States government, because the United States government say, don't give this information out. It may flow to the Five Eyes around the world, the Five Eye intelligence organizations.
Yeah, just to explain to everyone, ICE is a Finnish company.
Mm-hmm.
Actually, amazing company producing satellites, synthetic aperture radars.
Just SAR, right? Just SAR.
Yeah, SAR. They mostly concentrate on the low Earth orbit, but as you said, so they are a global company and they also serve to different governments, not only European. But this actually brings me to the next question. So that you already mentioned, and actually it already was in the first presentation as well. Like US has advantage of is it like one country. They have assets, they have all chain to the decision, and that all owned by one country. So we are fragmented in Europe. So we do not have. There is no European Space Force, by the way. And let me put this question this way: so how we can build how we can close this gap from the satellite to decision in European level? Because the most probably we won't be able to cover like all different assets by every single nation. Like imagine Latvia, we never ever will have like all different assets, all different satellites, right? We will rely on our allies, but we need somehow to build a decision-making process. Do you have any advice how to do that, or at least some ideas?
That's what you have to do. Basically, you have to build that decision-making process. You need to exercise it in war games, if NATO has war games, which they do. But right now, like I said before, the United States controls 80% of those satellites, and so most of the decision-making is running through. You got SAC, your strategic commander of Europe, which is an Air Force general, and U.S. Air Force general.
In Europe.
In Europe. And so he makes all decisions for NATO for that. So you need somebody lower level, or not lower level, you need basically a ability here within Europe to basically be able to task the satellites. You need to basically be able to process the data yourselves. You need to basically enhance the data, and you need to be able to disseminate the data out there to the warfighter, the user. And you have to have the autonomy to be able to do that. You don't want to be basically having to go back to country X, basically get permission to task that particular satellite. You have to have the autonomy to be able to do that. So you have to exercise that command structure within a European framework. And I don't think that command structure is there right now, because we do have NATO, maybe down the road there's NATO Next or European Army, whatever we want to call it. But right now you don't have that capacity to do that because of the tie-ins of NATO.
Right. So, will we have European Space Force?
I don't think so. I don't think you need a European Space Force. I think you basically need what I talked about before, the ability basically to be able to task. Not every country has to have the entire sovereign chain, mission chain. Each country may have to have, they're specialized in this particular asset. So we have ground stations. We do, Latvia does ground stations. I'm not saying that's Latvia does, but, Latvia's expertise is that. Latvia's expertise is basically doing satellite analysis work on SAR imagery. You have experts in that. Who's training the people, who's training the workers of the future, basically, to interpret that imagery. And so.
All right. So you already mentioned that 80% of all satellite assets, NATO satellite assets, are owned by US.
Basically, on open source, I don't know the exact number, but that's open source intel reports. You
Okay, that
pick
sounds
up that
pretty
Probably-
credible,
probably sounds
perhaps.
right.
And this is one of the reasons why European nations, particularly Germany, UK, and France, are rushing up, investing in just creating own assets. But just looking on the eastern flank, particularly in Latvia, so the national capacity is pretty limited. Do you have any recommendation? What exactly would be the most sense to invest in? What kind of assets? Like what are different? Like if Earth observation, it's SATCOMs, it's early missile warning, or some other things.
I would say that I would say push the decision chain closer to the eastern front, to Eastern European countries. Because if you're sitting out in Spain or France or in the UK, decision making is not going to be that quick. They're not feeling the threat like you're feeling the threat here. You feeling the threat here is you're down to seconds, so they're down to minutes. But so it really, you're getting inside your OODA loop, if you're familiar with that terminology. And they're basically making decisions faster than you're able to react to them. Even with AI, I'm not sure that is going to be able to be overcome unless you have the decision making a little bit closer to the front lines. People who are basically under the gun, as opposed to somebody sitting back in further Western Europe.
So that sounds already as a plan. I'm not in the position to make any plans for Minister of Defense, but it sounds like a plan. So, like, we need to have operators who operate satellite data and transform that into the recommendation for decision making here.
Right.
But is it correct to say that in order to have like seamless access to data, it would be wise to probably not launch own satellites, which is kind of expensive thing, but to contribute to our technologies, to contribute some joint satellite. Let's say if France and Germany now is building an early missile warning system, called JEVEL. So if like we can contribute that, is it correct to say that we would have more seamless data flow to our local operators?
Yeah, if I think I understand your question, basically who owns a satellite? And so if an EU country owns a satellite, you can make arrangements through a military structure that will be able to task that satellite. And so you would have that information more readily available to you if it has to pass through offices in DC, through the CIA or through other three-letter organizations in DC that may or may not get that information or approve that information being released quickly.
All right, so it's 10 seconds to the end. Thank you, John. I want to make the very short question at the end. So if Europe could change one thing, just one thing, to make ourselves more secure, what it would be?
Wow, that's a tough one. We're running out of time, but it's I think it's basically doing the entire mission chain. Make sure that you have that. A lot of companies want to put up satellites. That's very glamorous. My country has a satellite now, but if no one's using it on the ground, if no one's established a requirement for it, so you need to fix that process to establish. And I'm not saying it's broken. I just don't know that process because I haven't worked in that area. But I think that's what needs to be done. You need to look at the requirement before you start building satellites.
Thank you, John. So first users, then assets. So this is my takeaway from this discussion. Thank you very much.
Thank you.
I really appreciate you coming to Riga.
Thanks,
and
appreciate
I hope
it too.
It will be not the last time.
Okay, good. Thank you.
Thanks, guys. Thank you, John. Thank you, Michal. It's really good. Let's see. Let's move on to chips, semiconductors in conflict. The chip war is real. How are semiconductors deciding or decisive in modern warfare? I'd like to call up Benjamin Volba, who's a European Defense Tech Hub, building pan-European network for defense innovation. Are you head of that, right, Benjamin? Is that right? Yes. Okay, welcome. Welcome, Benjamin.
Hello.
Hello, hello.
Welcome.
Tell us about it. Semiconductors.
Yes.
You know they're crucial. They're in everything. But tell us more about that.
Absolutely. Now, semiconductors and modern warfare. That's a super broad topic. We could be speaking for hours. That's why I decided to focus for the next 10 minutes mostly on the modern warfare part and how this is shaped by innovation in computing. So, I'm Benjamin. We started the European Defense Tech Hub as a network for defense innovation, getting hundreds and thousands of people into defense. Now, this is more urgent than ever, as we can see from the daily news, but while we talk a lot about drones and missiles and all of those defense systems, what we should also talk about is actually compute. Now, not all compute is created equal, and not all countries are equal. When you were following the news coming from the US in January 2025, as the Biden administration was just on their way out, they issued the AI diffusion rule, basically dividing the world into 3 parts. There were the US and key allies, 18 countries. Then there were tier 3 countries that they would absolutely not sell any semiconductors to. And then there was basically everyone else in the middle, being a tier 2 country. And there was a huge public outcry in Poland, but also for what it's worth in Latvia and the Baltics, as those were classified as tier 2, which doesn't mean they can't get semiconductors, but it's a much more hassle and much more bureaucratic. Now, this rule did not come into action, as it was rescinded by Trump in May, but it really shows that there are a lot of geopolitical considerations around compute, and in this talk we're going to touch upon why that is and why that matters for modern conflict. Now, the title, Chip War, is actually borrowed from a book that Chris Miller has been writing. It's an amazing account of the history since World War II, going into the Cold War and how compute has really reshaped modern conflict, because it enabled precision. If your bombs are dumb, you might calculate the trajectory, but it might hit the target, it might not. If your bombs are actually smart, if they can course correct, they can actually hit targets very precisely, and that turned out to be a decisive advantage. At the same time, compute today enables much more than just targeting. Think of AI, think of data analysis, think of smart decision making. All of that hinges on compute and having advanced compute capabilities. Now, when you checked the news headlines this week, there was news about the new super tank coming from Norway, being lauded not just for its firepower, but also its long-range precision. That's exactly the point. They have a lot of sensors, a lot of compute. There goes a lot of smartness into how the thing fires to hit targets very far into the distance. Now, that basically encapsulates what we've been doing over the past 20, 30, 40 years. We've been building monolithic systems like tanks, fighter jets, warships, which were enabled by more and more compute to become more and more precise and smarter. At the same time, warfare has fundamentally changed, and these systems are now getting wrecked, as we can see it every single week inside of Ukraine. So what used to be the pinnacle of firepower and precision is now actually a trap, as these tanks are getting wiped out by rather dumb FPV drones. And now that is exactly the point where we're moving to. There's a transition that has happened that is as fundamental as the transition from knights fighting with their swords and their armor to suddenly people having guns and gunpowder. Doesn't matter how nice your armor, if the peasant shoots you that with the gun, you're gone. And in a very similar way, a transition has happened on the battlefield. They're now drones. They're unmanned systems. Oftentimes quite dumb, but as we've seen out of Ukraine, if you have enough FPV drones, if you have enough Shahed drones, you can hit targets, you can inflict serious damage. You don't really care if one of them is taken out because you have plenty. And that is exactly now the question that Glenn brought up from Defense Innovation Unit in Stuttgart. What role does compute play in this new age of autonomous systems and unmanned warfare? Now, when you follow him closely, it looks like compute is ever more decisive in now enabling all of these unmanned systems, all of these drones, where one part of the question is the communication link and infrastructure between them, but then also how do they process data? How do they actually find the targets, track the targets, and eventually hit targets, right? And compute could be as decisive as making sure that they have proper ammunition that properly works. Now, he was referring to an amazing article by the Atlantic Council. I can just recommend every single one of you to read this article. That's why I put the QR code here. It's great. It's much more holistic than just looking at drones and edge compute. It's also talking about data center infrastructure, just imagine, as Ukraine, they have terabytes of combat footage, which is now somewhere in the cloud. And you want access to this data. So there's a huge question around data sovereignty and having data centers available on site. But there's also a huge question around edge AI, and that's what I'm going to focus in this talk. So basically, the question is, you have these systems, drones, and they've proven very effective in combat. But most of them, still to this day, they use analog radio links, which can easily be jammed. And that renders them ineffective. If you're a pilot, your drone gets jammed, it gets lost. Bad. That is why people came up with, I can attach a fiber optic cable to it, which has proven to be one of the most decisive battlefield innovations of the past 2 years. But it's just a transitionary technology. It is, of course, not ideal to have the cable and fly around with the cable and get stuck somewhere. So what you actually want is an onboard AI, a compute, that is smart enough to autonomously fulfill the mission. Once the operator says, OK, hit this target, to go and hit the target reliably. That is why we need onboard compute. Now, we're sort of stuck in a situation, just to put it bluntly, between you can choose very expensive, very energy intensive, but rather capable compute. For example, you can take NVIDIA Jetsons. The disadvantage is also it's not as readily available as you're trying to scale from a couple hundreds or thousands to millions and millions of drones. And at the same time, you can use Raspberry Pis, you can do your own development with MediaTek and Qualcomm and others, but they're typically not as capable, even though they're rather energy efficient and cheap compared to NVIDIA. So we're sort of stuck in this middle where there's at least no clear winner, at least based on what we're seeing out of Ukraine. So people are experimenting a lot. They're talking to people who are basically pairing a Raspberry Pi and a Halo Edge AI processor to build their own system, which is sort of in between. And it's not perfect. And this is, by the way, exactly where I think Europe has an opportunity to shine. And I'm not going to dive into all the technologies that might enable this. We might do later during the panel discussion. But there's a lot going on, both when you look at, for example, what Acceler AI is doing with in-memory compute for digital chips. So staying as close to digital chips as possible, but adding in-memory compute to be way more energy efficient. Or going one step further, what Zemron is doing. They're doing analog computing, in-memory computing, but analog. So you need to have all the digital analog conversion in addition. And then there are also companies going completely beyond silicon, and people looking into photonic computing, such as Ecotonics, and exploring really novel technologies. And there's a whole discussion and opportunity around next-generation computing and what that might enable. Now, there's no clear winner yet, so people are experimenting and building pretty much with whatever they have. But the general trend, which is summarized here, is clear. We've gone from why is compute really important? Well, at least when it comes to traditional military power, because it enables precision targeting. Then going to building very bespoke systems like fighter jets, but having few of them, few relative to the amount of drones we could be producing. We've seen swarms, hundreds, thousands of drones emerge, but still being pretty dumb. And now the actual question is, how can we leverage compute to move that forward to a smarter system? We had this trade-off between very few dumb, very few but very bespoke systems, and many quite dumb. How do you move this efficient frontier forward to have smart, intelligent drones and drone swarms? Now, our contribution to that, just to touch quickly on it, is to build this pan-European network for defense innovation, the European Defense Tech Hub. We're a bunch of civilians. We're not an EU institution. That's why we write defense with an S. We're rebels. We show that we're fully international. And we started out pretty much by accident, running a very first European Defense Tech hackathon in Munich in June 24. We gathered 150 people, builders, mentors, developing solutions from air defense to demining over one weekend. Initially, because we thought it would be cool. And then we figured it's not just cool, but it actually helps people build companies and products. And that is why we kept going. That is why we organized 2 more in Copenhagen and Paris that year. And why we then scaled last year to 20 hackathons pretty much everywhere, all across Europe. Going to the UK, to France, to Poland, and yes, also to Ukraine. We've been to both Lviv and Kiev. And we think this is incredibly important. We're a bunch of civilians doing this without any NATO, EU, or government funding. We're doing it because we think it's the most important thing we could be working on. And we can help that way really get hundreds and thousands of people into defense. And there are a lot of stories that we can tell about what is actually coming out of this. Just to put three here, these are companies that were founded directly through or in the context of these events. We had Zero Industries come to a Warsaw hackathon, eventually build a startup, get VC funding, work on drone autonomy. We had Munich Dynamics come to a Munich hackathon, now work on cheap, low-cost interceptor missiles to take out enemy drones. With Trust Technology come to a Netherlands hackathon, now work on Shahad interceptors. So there are some tangible outcomes. We're not just doing hackathons, we're also supporting them. We're hiring talent, finding investors, everything else it takes to build a defense startup. Us, that's me, my co-founder Jonathan, and an amazing team of people. And if you want to work with us, please contact us, and we'd be happy to chat. Thank you.
Benjamin, thank you very much. Vielen Dank. Please stay where you are, because we're going big hand. Yes, big hand to Benjamin. Really good presentation. And we're going to continue with this idea of chips. Can Europe build the chips it needs to defend itself? We're going to continue this conversation with Jerzy Baratovic, Distribution Manager, Northeastern Europe, Infineon from Warsaw. Welcome, witamy. Welcome, welcome.
Nice to see you.
Nice to see you. And moderated by Sandis Saladas. You hold a number of hats, Sandis. You Latvian National Defense Academy among them, right?
Yes.
So I'll leave that to you. Thank you.
Yeah, thank you so much. I think really great insight, where Benjamin we agreed to go by the first name because otherwise the life is so complicated, technology is very advanced, it's like, let's not make it too difficult. And Jerzy, thank you very much for joining this panel. The question is about European capability to build its own semiconductor industry. What I know that without Europe, there is no global semiconductor industry. Like if one Dutch company cuts the supply of precision machinery, photonics, from the Netherlands, I think all technology supply chain would be in jeopardy. But at Riga Technical University, and Riga also during the Soviet times has been one of the Silicon Valleys. We have manufactured chips. At Riga Technical University, we have a specific semiconductor center. We are capable of testing, so we are building infrastructure, and we are about to become the next NVIDIA, but also for Europe, for design. We have the brain power and also the people that could work with such industry. But we understand that we are a small fraction, what Benjamin already said. It's like you need to know for which type of military capability you need a chip. And in Ukraine, you mentioned already their experience from, we are learning from our partners how to deter and defend against our adversaries. And in Ukraine, they are using very sophisticated chips that are bind together with the sticks and MacGyver tape to fight the Russian military. So it's very innovative and pretty much integrates everything that we can find in all the revolutions in military affairs to support their military objectives. But semiconductor industry is like dual use, and we need to build it up in Europe. This is something where Europe is lagging behind. We have been very good at defending prosciutto and French wine, but not Europe itself. But currently we have to grow up, and to keep up in defense, we cannot lag behind in technology. So I'll ask Benjamin, because like you are from the startups, right? So you are thinking big. Jerzy is like from the industry, so he has very structured view at the industry. Maybe we can start with Benjamin. What should Europe do? What should be the next step? Political, geopolitical, industry-based, like private sector, public sector, how to build up the semiconductor industry in Europe. So please, the floor is yours.
I think the first thing is to realize that semiconductors are as important as any other critical infrastructure, like access to energy, maintaining bridges. It is vital for us to have access to this technology. Now, when you look at the global semiconductor supply chain, it is very fragile, but part of it is actually in Europe. We have ASML building the original machines that you need to then manufacture chips. which mainly happens in Taiwan and Korea, while a lot of the chip design software and a lot of the chip sellers sit actually in the United States. So it's not that Europe has no semiconductor industry whatsoever. We have a certain share in the semiconductor industry, but as I guess we'll touch upon later, we don't have any leading edge nodes, which means the most advanced chips are not manufactured and oftentimes also not used here in Europe. We have a lot of automotive industry, we need a lot of edge compute, but not necessarily, producing the latest Mac with the latest, 3-nanometer chip. So in that, Europe has a, starting point with a lot of industry already, but we're not going to, outproduce Taiwan on GPUs. Or build the next, 2-nanometer node just like that, if there's not dedicated political will to actually make it happen. But at the same time, and that is what I was touching upon before, I think there's a decent opportunity as we have all of those next generation compute startups to actually get onto the next S-curve. The S-curve for GPUs, okay, done. Dusted. But at the same time, I think there's a tremendous opportunity to make use of older fab nodes, to really look into what is in there beyond silicon and really think from a strategic geopolitical perspective. Okay, so basically GPUs, okay, they stay in Taiwan, but what else is there? What can we uniquely do in Europe that is not just consuming more energy by building large GPUs, but really delivers more intelligence, more intelligently? And I think that's one of the key questions we should be asking.
Mm-hmm. Thank you. Yoshi.
So you have a lot of right, but we have few European companies. They produce at the moment a lot of semiconductors. Like Infineon is one of them, but also we have ST Microelectronics from Italy. It's also a European company. We can consider NXP also somehow European from Netherlands. But anyway, in Europe at the moment, we have some part of the production. Of course, we don't have this very sophisticated AI chips. It is completely out of our, let's say, possibility at the moment. But we have components for example, you mentioned this drone war. The components which are needed for drones, for these dump drones, we have in Europe at the moment. But of course, we can not all the steps we have, because in the semiconductor production, you have, let's say, starting from making the monocrystal of silicon, it's outside of Europe. Then making the wafers, partially yes, partially no. First, somebody needs to develop this layout of the chip. Also, we have some knowledge. We have some companies, European companies, specialized in designing the chips. And then we have after making the chip, you need to make the packaging. Also, we have few companies specialized in making the chip. So we have this capability. And what we have to do, we have to increase our share in these areas. But this is the area for the universities to train the people, because what we need the people, we need the knowledge, and we need the hardware, then we need the companies. And to get the people is a task for universities and also for governments to somehow motivate the young people to start learning in the technical schools, which is at the moment, as you mentioned, semiconductors, somebody mentioned before, semiconductor is the oil of 21st century. So we need to train people. And we have a lot of startups. This is another, let's say, very interesting point, because the startups usually they are very innovative. They can think outside of the box. They can develop something, some new technology, which is cheaper, maybe more efficient, maybe smaller, maybe better for the mass production. So we have, let's say, good starting point, and we need to develop it.
Thank you, Jerzy. Like, you're from the industry, you mentioned the human capital, right?
Yep.
In Europe, like, we are not as federal as the United States, where the movement of the people and the procurement of the talent by the corporations is very efficient, right? And you mentioned universities. How do you think, how could industry and universities cooperate to make sure that we get the best professor that will teach loads of students, because the industry is inclined to buy the professor, and then it's basically the dumbing down of the student pool, and we don't really build up this capability sufficiently as they do in Taiwan. Like, they reinvest 10% of the turnover from the semiconductor development in brain, in research and development, to make sure they are number one. If they are two, then or second to first, right? Like, they are already facing geopolitical consequences, right? For them, this is really the acid test. For us, like we are in this position where we can transform. But how to do this? How to build up this capacity from the perspective of industry? Is industry mature like in Poland? We pretty much like from the Baltic states follow what's happening in Poland, and we are really willing to fill the gaps that exist.
No, the situation in Poland is also not that, let's say, perfect. So everywhere, the let's say cooperation between the business and the universities is something which can be improved. So what I can see in many countries, I'm responsible for Poland, but also Baltic states, Czech Republic, and I can see sometimes it works, sometimes not. And this is the area definitely for improvement, because usually universities are interested in developing new technologies, teaching new engineers, but the support from semiconductor players, semiconductor producers is not that good as it should be. So definitely this is the task for me, for us, for semiconductor producers, to invest more time, more resources to the universities. Definitely we need to improve it.
Thank you. So Benjamin, me and Jerzy, like we have this one constraint, like when we go out, you sometimes have to say something or sign something that we will not share the technology. You are coming from the area where the transfer of technology and of the people and the knowledge, right? So you are the most agile and dynamic. How do you see, how can we build up this human capital and knowledge like in Europe? What's the source, or who should lead? Like Brussels, like Warsaw, Riga? Who should take the responsibility? Or there are so many focal points in Europe that we cannot really build region-wide capability?
I mean, first and foremost, it is the responsibility of every single person to take action. And to, it's all our responsibility. We started this network, European Defence Tech Hub, not because we were told by any government agency, because we thought this is the most important thing to do. We just saw it worked. And most of our initiatives, be it new events, be it, building up our investor network or whatever, they started with one person banging on the table saying this needs to happen. Every single one of you can talk to people, can write a blog post, can organize a meetup or a hackathon. So in that, every single one's responsibility is to make sure that we're strong and sovereign as Europe as a whole. And maybe to give you just a very different example, like there's a lot of talk about universities. Of course, they operate at scale. They have lots of students. That's where the majority of people go. But at the same time, we need examples for inspiration. And we need those lighthouse projects that really show what is possible. And one such project is actually not very far from here. And it's called Freight, FR8. Who has heard of Freight? Not that many people. It's a hacker house in Helsinki, Finland, and it's funded by venture capitalists. They got an old university building, 12,000 square meters, and they're incubating projects there. Projects dedicated to neuroscience, to computing, to next generation AI, really to get the best builders around the world get together for an in-person startup program to develop those further and eventually fundraise. And this is just one example of, yes, we can go the traditional way. We can look into university startup incubator programs. And, I think NVIDIA and CUDA, they've done a tremendous job doing education and making, people familiar with their products. But then I think one thing that we can really look into is also the Silicon Valley spirit, hacker houses. You sleep together, you work together, you really build density of talent. And I think that is what we are sometimes also lacking in Europe. It's very decentralized, which has a lot of merits, but at the same time, it's also really good to have those few examples you could point to. This is the best place in the world to do semiconductors. This is the best place to do something else. That's where I think examples like Freight are incredibly valuable.
Thank you. I think your spirit and approach, right, to Brussels to educate the bureaucrats and reform European Union. Jerzy.
So I would like to add that this is a very good, let's say, point of view, because especially in Eastern Europe, we from Eastern Europe, we are very creative. We are eager to work, and we have to use this, let's say, maybe the shorter decision path that, for example, in Germany, they need to think, they need to consider, they need to elaborate, to discuss with the trade union and so on. In Eastern Europe, the decision path, even if we have this European bureaucracy, is much faster and much easier to make the decision.
Absolutely. Here, we are really dynamic, and it's
also we are more motivated to do it.
Absolutely.
Comparing to, for example, Spanish or Portuguese.
German, Irish, right? they do not join EDF projects because the hourly rate is too low for them, right? We are motivated to build something for defense because we know if we don't, like, they will be in trouble. So we have to be a responsible part of Europe.
We see the Russia just behind the corner. So
Absolutely, absolutely.
This is something which motivates us.
Absolutely. Germans are living with the fear about the too low hourly rate, like we are living like security concerns, right? But in Ukraine, the fear is completely different, and we are seeing this. It kind of reminds us about the history we were in. We don't want to be a vassal again. I would like to turn to the audience for a question. I don't want to hijack the show alone. If there is a question, please raise your hand. I can see there's a gentleman to the left. Please present yourself and the question.
Hello, Chris from Start School. Question, what about PTSD regards defense? Would you put it in the same section, PTSD, inside in the defense innovations or no? Or it's an aftermath after something happened?
What do you mean?
Post-traumatic
stress disease?
Yes.
Yes. So, about cognitive stuff, you know, how could like artificial intelligence information, can they heal or not? That's what you mean, right?
No, mostly like PTSD. Will it be somehow extra funded regards war that is happening or something, or we will gonna fund only anything that regards defense and attack?
Maybe to pick up this question, when we talk about defense, it's usually not just missiles and bullets, but really in terms of total defense, it is much more comprehensive. Also, of course, touching on first aid, touching on logistics, touching on everything that also, you know, enables society to be resilient. And in that sense, of course, we need to also think how we, you know, treat the wounded. There's an amazing project called Superhuman in Lviv, and where they've, you know, prostheses, and you know, you lost a limb, you get a replacement, and of course this is something to look into. It's a, you know, bit of out of focus for a compute panel, but in principle, it's of course very important to think about this holistically.
Jerzy?
To be honest, I don't understand the question. What is the relation between the PTSD, which is typical for the people which are take some action in some, let's say, war or some conflict?
Yeah, recovery.
And how is related to defense?
Like basically, I think rotations maybe, yeah, preparation of the.
Because
yeah.
We are preparing. We are say what we would like to do. We would like to build the system which will threat our potential enemies, not to attack us.
Exactly.
But the PTSD, we should do everything to avoid this.
Yeah, that's true, but like it's very difficult if you have been on the front line, and maybe like this rotations, right, where you rehabilitate like the soldiers, and they are being sent back to, if we can use technology for this. I think technology might not be we are not thinking about this, but this might be something that is really open to industry and also to innovators to think about, because we have to be resilient as Ukraine for 5 years, right? You have to be able to move the humans, like the military.
Some rotation.
Yes, absolutely. I think it's a really great discussion, like at Riga Technical University, testing and design for the industry. You already know the solutions, and what Benjamin said, like they are really open and able to integrate different kind of ideas, apply to the drones and hardware, but also we have to think about other areas. And defense is becoming really dual complex in a way that is very difficult to craft. The new military doctrine is basically everything. With this, I would like to thank the speakers, and I think they deserve a round of applause. Thank you so much.
All right.
Thank you, Benjamin. Thank you.
Thank you.
Thank you.
Jerzy, dziękuję bardzo.
Thank you.
Thank you, Sandus. Great. A final speaker today. We're talking about quantum computing, the architecture problem, quantum computing defense readiness, and Europe's scalability gap. We've talked about scalability a number of times today, and now with quantum computing, let's talk about that with Stefan Schmid, Head of Tech Partnerships at Parity QC, which stands for Quantum Computing. Parity QC. Stefan, please. Big hand to Stefan. Welcome. You've got the.
Thank you.
You got the power there. Okay.
Yeah, thanks for having me today. As introduced, I will talk about quantum computing architectures today, and it's basically its impact on Europe's sovereignty. Yeah? But before going into the architecture part, let me maybe start with motivating and introducing you to quantum computing in general. And for this, I took an example from one of the major players in quantum computing today, which is IBM. And if you look at their roadmap and what they are doing, and basically their history, you see that going from basically the first computers through the mainframe era, the PC era, then now the data and AI era, the next big thing, at least according to their view, or one of the next big things is actually quantum computing. They call it the quantum era. They see more or less these qubits, which is basically the basic information unit of a quantum computer, kind of in a similar level as the bits and neurons for compute and for the AI era, more or less. If you look at now basically at a very actual picture where they propose how quantum computing will be integrated, you will find on the website this page, which basically should depict how several processing units of a basically state-of-the-art or future HPC center will look like. So today we know, of course, CPUs and GPUs, and the vision here is basically to add quantum computing processing units or quantum processing units to an HPC center in the near and mid-term, I would say. So that was basically one thing. So now one can ask, this is basically what's going on in the US at the big enterprises, but there is also, of course, a lot of things going on in Europe on quantum computing specifically. So, and basically all the startups, all the organizations that try to basically be part of this quantum computing endeavor, they are, almost all of them are basically supported by the European Union. And to strengthen that effort, actually European Union has announced the Europe Quantum Strategy very recently, so last year. And basically in very high level, the idea is to become from the leader in quantum research, quantum computing research, or quantum research in general, to a leader in quantum industry. So that tackles not only quantum computing, but also includes also quantum computing, of course. If you look in more detail into this program, you will find 5-6 bullet points. So basically stay ahead in research, so not only transferring it to industry, but also staying ahead in research. The European Union announced 6 so-called quantum pilot lines. So there are 6 different major hardware platforms that people try to build quantum computers with. And Europe has basically dedicated for each of these technologies a pilot line. Then, of course, investments in general in companies, build up a venture capital for that purpose, supply chain, and last but not least, of course, its influence on defense is also basically a dedicated pillar here, and basically included in the defense strategy of the European Union as well. And of course, education is, as we have heard for other fields today, also a big topic. Now, what is the impact now of this whole endeavor, quantum computing, on the sovereignty of Europe? So I took basically 2-3 examples here. So the one I'll talk a bit more in detail is what I would call the information sovereignty, and here is probably the most important example of a quantum algorithm you can see here, which is the so-called Shor's algorithm. And the Shor's algorithm is basically a quantum algorithm that can decrypt state-of-the-art today's cryptography that we are using in many ways today in all the communication we do and so on. So that's obviously a part where sovereignty is impacted and needs to be considered. But this is not all of it. There is basically what I would call the economical, industrial, and technological sovereignty, and there are a few examples and a few algorithms that are relevant here. So one is the optimization algorithm, which is for today's quantum computer is typically discussed as this so-called QAOA. This is the name of the algorithm. And basically here we talk about use cases such as logistics, supply chain resilience, supply chain optimization, and also in a defense context, triage optimization, things like this. Then there is a bunch of algorithms to solve complex mathematical problems, differential equations and linear equations, and this of course has also impact on defense or sovereignty relevant things. For instance, this HHL algorithm is discussed in terms of optimizing electromagnetic scattering when it comes to radar cross sections, for instance, or for finite element calculations. And the last pillar here of groups of algorithms, more or less, is the so-called quantum simulation. That includes actually many different things that you can do. The most important things from a defense or from a sovereignty perspective is I would say, is this material science part. This is, of course, highly relevant to research new materials. And as an example, I put here high entropy alloys or high temperature superconductors. And the other thing is the whole field of biochemistry, where one would search for new medication, and basically is of course also a highly relevant sovereignty topic here. The field of quantum computing is just very brief, is very competitive. You see that here there are a lot of startups. This is a McKinsey report from last year. So this is not only a bunch of startups, it really has grown basically to a global effort already. Now the challenge here is now that this is a race for basically this triggered a race to quantum advantage, and today we talk about the so-called era of noisy intermediate scale quantum systems, NISQ. And what will happen is now the transformation to so-called fault-tolerant quantum hardware, which is basically hardware where errors that occur throughout the calculation are corrected for. And then this is expected, and we come to the word scalability here, that this is actually the hardware that will be scalable, and that is expected to be then really take over more or less in these specific fields the lead in computation. Now, the big challenge here is the control of the qubits. So a quantum computer is usually very susceptible to noise, so controlling an information unit, a so-called qubit, is usually a very demanding task if you compare it to bits in a regular computer. And so controlling this is and scaling this is not only, one would think this is basically just a matter of building a better quantum computer like a hardware developer does, but it's important to realize that it's also a topic of how to arrange qubits, how to connect them. It's a so-called architecture problem, and this is also connected to the actual software, to the actual way how I implement an algorithm on my system. And that's why that's where the architecture more or less comes in. Now, this is to understand this a bit more in detail. We put here this so-called compute stack. You will find that for a classical computer in a similar way. And what you basically see here in the very top is your application, the thing that you want to solve, the problem that you want to solve. And the very bottom is basically the hardware, basically the device that you want to solve the problem with. And in a classical computer, most people who kind of want to solve an application or run an algorithm, they don't think about what's happening in between. It's basically you give a program and you put it on you turn enter, and then the program runs and is executed on your hardware. The reason for this is that for a classical computer, these intermediate layers are usually very standardized. Yeah? I mean, of course, they're further developed, but they're usually very standardized. And they are made in such a way that the user and the application layers don't have to worry about it, more or less. Now, for quantum computers, since the technology is very young, this is not the case. So this is a very active field, and this is not yet settled. And that's also a chance, in a sense, because even if for a continent or for a company that has a hard time to compete in quantum hardware, because it's very resource intensive, very capital intensive, well, a company can still compete in the layers, in the so-called system layers or architecture layers in between. So when we talk about the architecture layers, we're talking about these middle layers in between. Now, what do these architecture layers include? So it's one thing is this algorithmic implementation, how I take over an algorithm and how I implemented it. The next one is then to basically take into account how the hardware, how the qubits on my hardware is connected, and basically synthesize the algorithm, yeah, so that I can put it on the hardware. And the last thing is the thing that is heavily discussed at the moment, and as I mentioned before, this is this translation from a so-called logical qubit to a physical qubit. So what this means is that for several, for basically when I have errors in my computer, I need several physical qubits to have one logical qubit. And I need that basically to be able to correct for errors. And that kind of thing, that will happen in between the layer where the problem is processed and the actual hardware. Now, as I mentioned before, this is basically the challenge, these architecture layers here, and that's also where people try to set. And of course, if I come now to basically what a company like we are doing, where we are basically have seen that it's very hard to compete with hardware, as for the reasons I mentioned, for the whole capital but intensive way that hardware development needs to be done. We try to basically work in all these middle layers in here, and basically try to develop methods that can basically, where an application can then basically put efficiently on a quantum hardware. Now, coming to the hardware, this is maybe important to note and also interesting for the audience here. So there is not a single type of technology that quantum computers are built with today. So there is 5, or there's even 6. One is even missing here, the so-called photonic quantum computers. But there is for sure these 5, they're typical platforms. So these are really significantly different technologies where people try to build quantum computers, and it's not yet clear which of those technologies will in the end survive or win this race. So one is these superconducting qubits, neutral atoms, trapped ion spin qubits, so semiconductor qubits, and so-called nitrogen vacancy centers. And I run over this, but I put a bunch of names here, and it's for sure not complete. It should list the most important players in each of these fields, but just from the fact that you see that there are multiple companies in each platform active, should show you that companies are still thinking that the race is not yet done. And what you might recognize is that the big corporates are playing in this field here. So if you take, for instance, Google, Amazon, and IBM, and they have done so for multiple years. IBM's program is basically there for 10 years now, similar for Google. But interestingly, for instance, Google has announced recently, 2 months ago or 1 month ago, that they will also be active in this neutral atom field now. Yeah? So they will collaborate now with a startup, and will also basically have a dual way to see that, because they have seen the drawbacks of the superconducting platform and decided to also look into another platform. So each of these platforms has some drawbacks and has some advantages. And again, it's not decided in the end who will win. The thing is now, what a company like we, as an architecture company, can do, we can now take a quantum algorithm and try to map it on on one of those quantum computers. In the end, in a very simplified way, a quantum computer, the quantum computers you have seen before have different connectivities, different ways that the qubits are connected. And together with other features like the quantum gates you need to process, this is typically called the instruction set architecture. This also exists for classical compute, and this basically was turned over, the term was turned over for quantum computation as well. Now, if you take a square grid, for instance, and the most common way qubits are connected would be a square grid device. So here, one qubit has 4 neighbors, and 4 neighbors that it can talk to. Yeah? And now the question is, how do you map an arbitrary algorithm on it? Yeah? Where you, for instance, the algorithm tells you that this qubit also needs to talk to this qubit down here. And the solution, basically, typically the state-of-the-art solution for this is a so-called swap network. So you see all these. This is a picture of gates. So this line here is basically a gate between the qubit here. So each line is a qubit, and each vertical line is a gate. And you need to perform a lot of gates just to distribute the information across your quantum computer. And in our case, for instance, as an example for architecture, we came up with a different technique to basically spread information across the device. Yeah? And you see that this circuit here, so this way to transfer information here has less gates, so less vertical lines here, and has also a smaller so-called circuit depth, so a smaller duration of the circuit, a smaller time to solution indirectly then. Now, yeah, let's jump over that. You can do that with other devices. Now, why is this relevant for the use cases we have seen before? And I'll take that as an example again, the RSA cryptography. So this is again the use case where basically which we use in secure exchange of information. And RSA is typically basically relies on the fact that prime factorization in a classical computer is an exponential problem. So it's you can take 15, for instance, and look for the primes, which is 3 and 5, right? And this is very easy. Everybody will, not everybody, but most of us will find the prime numbers. But for a very large number, it's very hard. So that's what RSA is built on, and the point is now with quantum algorithms, you potentially break those codes, so you can find these prime numbers much faster. Yeah? And this Shor's algorithm that I mentioned before looks like this. We don't go into the details. It's just, you see, it's quite a complex way that you need to do, but in its heart. So this is basically a quantum algorithm, or has a quantum algorithm in its heart. And this can be, in a future quantum processing unit, we will be able to run this algorithm. Yeah? And this algorithm basically turns an exponential problem into a so-called polynomial problem. So in a problem that is actually solvable for large sizes. Now, if you look at the details here, you will find a so-called building block basically one piece of this algorithm is the so-called quantum Fourier transform. And with the method I tried to motivate you before, I would just like to show you a very recent result that we have obtained, which is basically how to put a quantum Fourier transform, how to do a quantum Fourier transform on an IBM quantum computer. And you see basically the the blue line, that was basically with all the methods that I've shown you before, basically the left picture with the large number of gates you need, and with the much smaller number of gates is basically the red dots with the method we presented. And this should just show, and the plot basically shows, that I have much larger signals for this quantum Fourier, for this piece, for this building block of Shor's algorithm, for a higher number of qubits. On the x-axis, you see. And that's also the number of qubits we are talking today on a quantum computer. So, we operated this quantum Fourier transform up to 50 so-called qubits. And also for other problems, you will find all experimental studies which are done today are on the order of 30 to 100 qubits.
So is that you guys, Aumann and Fellner, in 2020?
Yes, so this
that's
is
you.
Yeah, that's us, right?
That's exciting. That's exciting.
That's basically our group here, and it's actually in collaboration with IBM, with multiple teams at IBM. And of course, IBM is looking for these these use cases, or for these implementations like ours, because that's of course motivating their hardware development. This is, of course, now you can ask, okay, this is only a small piece of Shor's algorithm, right? This is a very small piece. Will not decrypt RSA tomorrow, but it should just show, that there is something going on.
And to develop this, you had to do this transatlantically, right? You had to work with IBM Boston to do this.
Yes. So
this is not uniquely European.
Well, yeah. This is this is actually the name of the quantum computer. They named their quantum computers after cities. So that's not IBM in Boston, but
IBM.
So actually the headquarters in Yorktown, where the quantum computers are developed.
Yeah.
And so we also so there is actually 3 teams we are typically in contact with.
So does that mean that tech sovereignty, is that something that is not feasible because we have to work together with?
Yeah. So that's actually brings me to my your question brings me to my conclusion slide.
Good. Good.
So why did I show you this our example, which is very recent, which we think is really a highlight, because it shows you that even though, of course, if we can compete with building quantum hardware, that's the best thing, and we are also trying this with the pilot lines I mentioned. But this will be, again, like for classical compute, a very tough challenge. But we also have other chances, and the chances, like our example should show, that if we provide the best implementation of an algorithm, like small like one layer of this quantum compute stack that I showed, we already are engaged with the global supply chain, in this case with IBM or with other players. And that, I think, European companies, that's what European companies should do in quantum computing, but maybe in classical compute and in general.
Yep.
To engage, to make not only us dependent on IBM hardware, but also make
them dependent on
them and end users in, say, pharmacy, depending on our IP.
Yeah.
And I think that's a very important message for Europe, I would say.
Great.
Yeah.
Okay.
And with that, I want to close. Yeah.
Stefan, thank you so much. Thank you very much.
Thank you.
I wish I could go to Q&A, but I think we'll have to leave that for the networking reception, which will come in just a few minutes. I just want to wrap this up and thank all the speakers, thank the technicians, the producers, the sponsors that you can see up here. We have covered so much ground on drones, robotics, space, batteries, chips, quantum, cybersecurity, and talking about the Baltic Tigers innovation. It's quite fascinating and inspiring for me because, in part because I grew up with a father who worked at Lockheed's Skunk Works. I don't know if how many you know about that, but that's where they built the U-2, the SR-71 Blackbird, which at the time was the fastest plane in the world, and all that. And Dad coming home and giving me, this little kid, a titanium screw. Was wow. So, I've been gee-whizzing wow all day. It's been very inspiring for me. I hope for you too, for investors, for startups, to give you hope that you can do this and that we can work together as Europeans and maybe even internationally to better the world. Hashtag Deep Tech. Put that up on the social networks. Networking reception starting at 18:30. Tomorrow, be here at 10 o'clock. We start with Deep Tech European success stories. So that'll also be very exciting. I'm Chris Burns. I hope I covered everything. Anything else to point out? That's it. Thank you very much. Thank you. Great to be with you.